This is a general English question. A fill in the blank type of statement has been given. We need to fill the appropriate word in this blank. So they're saying that we reached the station late and dash missed the train. So they're trying to convey the fact that because they reached the station late, they missed the train. So now we need to fill the appropriate word in this blank, which would act as an adjective for this particular verb that they have missed the train. But how did they miss? That we have to fill over here. And we know very well that if we have a noun, then before that we put an adjective. But if there is a verb, which in this case is here missed, before a verb, in order to add more meaning to that verb, we add an adverb before it. So in this particular blank, we will need to fill an adverb that would add more meaning to this verb that is missed. So they definitely missed the train, but how did they miss? Either they miss nearly, utterly, mostly. Near would not be the option because it is not an adverb in the first place. So now among these three, they utterly miss the train. It does not suit very well. Similarly, they mostly miss the train. Now this mostly indicates a possibility, but it is a fact that yes, they have missed the train. So we will go with option B, that is nearly. If they would have reached the station late, they nearly missed it, which means had they reached a bit earlier, they would have definitely caught it. So this nearly would be the best option for this place. So we'll go with option B. This is a general English question. We have been given two sets of words, kind, dash, which we need to fill, and the second set of words is often with frequently. Now in terms of word meaning, we need to fill an appropriate word in this place so that the relation which is there between these two words, that same would get followed between the first pair of words. So if we have a look at this, often and frequently, they seem to be the synonyms of each other. We usually use them in place of each other. In the sentence, as you can see, he often plays piano, and similarly, he frequently plays piano. So both are on the same grounds, they're synonyms to each other. So in the same way, over here, we need to fill one such word which would be having the synonymous meaning with the first word, that is kind. So from this given options, we will find out which of them is the synonym of kind that would be fitting over there. So looking at the first one, that is mean. Now this mean is in the negative sense. It would say that he's very mean or he's very rude. So this mean implies rudeness, but we actually need kindness. So this would not be the correct option. Then coming to the second one, that is type. Now when we use it in a sentence, it would be like he's a very angry type of person. Similarly, he's an angry kind of person. So this kind and type often go synonyming with each other. So they can be said to be implying the same meaning when used in a sentence. This could be the correct option, but let us see if we have a better choice later. Third one is cruel, which is again in the negative sense. He's very cruel, he's very kind. Both seem to be opposites of each other. Then coming to the last one, that is kindly. Now this kindly, it is just the adverb form of the original word that was kind. They are not synonymous, they are the different forms of the same word. So this kind and kindly would not fit over here because these two are two different words. They are not the different forms of same word. So the same relation will not be holding true over there. So now the best option we are left with is this option 2, that is type. So kind and type will also imply the same relation as it is there in the next pair of words. So we'll go with option 2, that is type. They are saying that we have a series of natural numbers from f1 to f7 and so on, which obeys this particular recurrence relation. What is it? F of n plus 1 equal to f of n plus f of n minus 1. So this is the same recurrence relation that is there in the Fibonacci series. So we can say that the given series is also a Fibonacci series. But now let us look at the constraints. For n greater than equal to 2, f6 is 37 and f7 is 60. So the Fibonacci series, which we already know, which starts with the first two terms as 0 and 1 and moves in this way 2, 3, 5, 8, 13, 21, then we have 34 and then 55, so on. So in this series which starts with 0 and 1, we can see that these two numbers do not occur. So they're definitely not talking about the original series that we know. This is the given series is also a Fibonacci series, but it would have some different starting point instead of this 0 and 1. That is when it will have its 6th and 7th term as 37 and 60. And that's what they're asking us to find. What is F1, which means the starting number for this Fibonacci series. So now how will we approach it? Let us write down all the terms from F1 to F7. And we will use the given two terms in order to get all of the remaining terms of this series. Let us see how. F6 is given as 37 and F7 is given as 60. So now using these two terms, we will determine the entire series. And how would that be possible? Let us come to F5. We know that F7 will be the sum of its last two terms, that is F5 and F6. So we can say that F5 will be the difference of its next two terms, that will be F7 and F6. And same way we can just modify the given recurrence as F of n, you can say, equal to the difference of F of n plus 2 and F of n plus 1. Or in the better way, we can write it as F of n minus 1 just by modifying the original equation equal to F of n plus 1 minus F of n. So whatever we take, it simply implies that a given term is the difference of its next two terms. So now using that, we will determine F5 as 60 minus 37, that will be 23. Then coming to F4, it will be the difference of these two, 37 minus 23, that is 14. Then this F3 will be the difference of these two, 23 minus 14, that is 9. Then this F2 will be the difference of F4 and F3, that is 14 minus 9, 5. And finally F1 will be the difference of these two, 9 and 5, that will give 4. And that is what they had asked us, what is the value of F1. So for the given Fibonacci series, we got that the starting term, initial term is 4, and then it follows the same recurrence relation. So the answer for this question would be 4. This question is saying that a survey was conducted for a certain year and it was found out that 90% of the pregnant women received medical care at least once before giving birth. So what does that imply? Let us say the total number of women was 10. Out of them 90%, which means 0.9 n women received medical care in their duration at least once, while the 10% of women did not receive any care. Next, it says that of these women, which means out of those who received the medical care, out of them 60% received the care from doctors, while the remaining 40% received care from other healthcare providers, means not doctors, but there might be some NGOs or some organizations which might be providing the medical care to them. So now what does that imply further? That out of these 90% women, out of these 60%, which means 0.6 out of this 90%, which means the total number of women here will be this many. These many women received care from doctors, while 40% of those who received a treatment, which means this, they received a treatment from other healthcare providers. So now what does this become? 0.54 n and 0.36 n. So this is the percentage of women who received care from doctors and from healthcare providers. So now, given this information, which of the following statements can be inferred with certainty, which means which of these is definitely true? That is what we need to identify. So now looking at the options, the first one is saying that more than half of the pregnant women received medical care at least once from a doctor. Now, all these scenarios are talking about at least one itself, so that is not a point of concern. But we need to see if more than half of them received the care from a doctor, which means from a medical care they have received. So now looking at these statistics, we can see that here 54% of women have received care from a doctor, 36% women have received care from a healthcare provider, while 10% of women have not received any care. So now there are these three categories: 54% from a doctor, or you can say medical care, 36% from other healthcare, and 10% have received no care. So now what does this first option say? More than half received care from a doctor. So yes, that is true. 54% have received the care from doctor. So it's definitely true. Let's also check others. Less than half received from a doctor. No, more than half have received, so it's incorrect. More than half received care at most once from a doctor. Now there is no mention of at most once. All of the given information is saying about this particular case at least once only. So again, this cannot be inferred with certainty. Less than half received medical care at most once. Again same, at most one, less than half. Now this might be true that if more than half are receiving at least once, then less than half might be receiving at most once. It might be possible, but definitely it cannot be inferred with certainty. So we will also not go with option D. The best choice here would be option A itself.
This question belongs to GATE 2023 paper and belongs to the aptitude subject. So the question states, looking at the surface of a smooth 3D object from outside, which one of the following options is true? The surface of the object must be concave everywhere. The surface of the object must be convex everywhere. The surface of the object may be concave in some places and convex in other places. The object can have edges but not corners. Okay. So first of all, let me tell you what is a concave lens and what is a convex lens. So a concave lens is like this. This is the polished side and rays come from this side. And a convex lens has polishing inside and rays come from this side. Okay. So what we can do? We can basically combine a concave lens and a convex lens. So both of these can be combined like this to make a concavo convex lens. Like this can be concave, this can be convex, and it can be like this. Okay, so we can basically combine the two lenses. So this is either it can be concavo convex lens or it can be convexo concave lens based on how we combine these two lenses. Okay, now see, one of the side is concave and other side is convex. These concave and convex lens, how they are formed? So we basically have a sphere with a polishing and they can be taken out as a part of a sphere. So we can take out some parts. So if we have polishing inside, so if we have polishing over here, then this will become our convex lens. And if we have polishing over here, then this will become a concave lens. So, and this is a 3D object. And as we cut out the pieces, so lens is also a 3D object as it is formed from a sphere. Thus, we have a 3D object, a smooth 3D object. And what is a smooth 3D object? See, first of all, let us see the options. The surface of the object must be concave everywhere. No, we can have concave and convex both. It's false. The surface of the object must be convex everywhere. No. Now only these two options are remaining. Now see, the texture of this object is smooth because it will have continuous even surface. We have polishing and it is a mirror. So it's a smooth surface. Okay, it will not have any holes or bumps or any rough surface. Okay, so this is a smooth surface. Now we need to see whether the object can have edges but not corners. See, option C is true. The surface of the object may be concave in some places and convex in other places. C is for sure true. Let us see option D. So option D. So here we have edges. So what is an edge? Edge basically means straight lines, like at a point. See, let us suppose that we have an edge. So edge means a straight line. Okay, but here we can see there are no edges. It's just a curved line. So in this question, a edge basically means a straight line, non-curved lines, non-curved lines. Okay, then option D is also false. So answer is option C.
In this question, a passage has been given, and based upon that, there are these four options from which we need to determine which of them can be logically inferred with certainty, which means which of them is directly implied by the given passage. So let us have a look at it. The country of Zombieland is in distress since more than 75% of its working population is suffering from serious health issues. So what is it saying? That more than three-fourths of its working population is suffering from health issues, and that is the reason why the country is in distress, which means the government is stressed about this particular scenario and it is trying to do something for it. The studies have been conducted by competent health experts, and that concluded that a complete lack of physical exercise among the working population was one of the leading causes of their health issues. So now this is for sure that yes, there is some health issue going on within the working class of this country. And what was the reason derived for this? Studies were conducted and they came to a conclusion that lack of physical exercise was the reason behind this. And hence, further, they are saying that as one of the measures to address this problem, the government of Zombieland has decided to provide monetary incentives to those who ride bicycles to work. So now the cause of the problem is clear as given by the health authorities, that there is a lack of physical exercise among the working class, and that is the reason for the degradation in their health. And hence, as a solution to address this problem, what has the government decided? That it will provide some monetary incentives to the people who will ride bicycle to work. Now, what does this statement imply? That people have to be engaged in physical activity and then only their health would get better. And as the community health, as the health of the working class of the country increases, then the health of the entire country will also increase, because it is the working class who runs the country. So now, what is the solution that government has decided? In order to engage people into physical activity, that some benefits would be provided to those who will ride bicycle to work. So now what does this imply? That riding bicycle engages people into physical activity. So riding bicycle is same as doing physical activity or engaging in physical activity. That is what the government believes. So now based upon this, let us check out the options. First one is saying that all the working population will start riding bicycles. This may not be true, because not everyone would run behind this monetary incentives which are being provided. There would be some stubborn people who would anyway not stop their usual habits. They won't suddenly start riding bicycles just for this benefit. So this cannot be inferred. Next, riding bicycles will ensure that all of the working population is free of health issues. Now here this word all is the problem. Not everyone will start riding and not everyone will get free of health issues all of a sudden. So again, this cannot be implied. Next, the health experts suggested to the government to declare riding bicycles as mandatory. Now, a thing like this cannot be mandated, and certainly the health experts did not suggest to government for doing any such thing. It has not been proposed in the given paragraph. So again, that is incorrect. The government of Zombieland believes that riding bicycles is a form of physical exercise. Now here, believes that riding bicycle engages people into physical activity. This is what they might have thought, and that is the reason why they came up with the solution that whoever rides bicycle to work will provide them some monetary benefits. So this is was the thought process behind this must have been for the government, and hence we can say that yes, option D is the correct choice for this one. In this question, we have been given two functions, f of t and g of t, which are the functions of time that is represented by t. F of t has been defined as 0.01 t squared, while g of t is defined as 4t for all the positive values of t between 0 to infinity. So now they have given these two statements and we need to identify which of them is true. So we'll first determine among these statements 1 and 2 which is true or false. So now the first one is saying for some t greater than 0, g of t is greater than f of t. And the second one is saying that there exists a time t such that f of t is greater than g of t for all the values of time after that. So instead of substituting some values and then checking, it would be better if we simply convert these into graphs. Those are the simple functions, so we can easily create their graph. So this is 0, the time. Let us see if there is any value at which both of them will intersect each other. So for that we'll just solve this. 0.01 t squared equal to 4t. So one solution we get t equal to 0 because obviously at time t both of them are at 0. Another solution that we get by cancelling out 1t is 0.01 t equal to 4, which means t equal to 4 upon 0.01, that is nothing but 400. So this 400 is another point at which both of them will have the same value. And what will that value be? We can substitute t equal to 400 at any one of these. Let us say 4 times 400 over here, it will give 1600. Even if we substitute it in this function f, it would give the same result. So at t equal to 400, both of them get some value, let us say here, that is 1600. So now these are the 2 points from which both the functions will definitely pass through. Now other than that, if we look at this function g of t, it is a linear function. So it will simply grow like this up to infinity. And looking at this function f of t, it is a quadratic function 0.01 t square, and we know that the graph of a quadratic is a parabola. It will be an increasing parabola like this, and at 0 it is at 0. At 400 it has to be here. So now will it be above this line or below this line? We can try substituting some value, otherwise it is not that difficult to visualize it as well. Let us substitute t equal to 1 just for understanding. Then its value becomes 0.01 times 1 square, which is nothing but 0.01. So at t equal to 1, let us say we have 1 over here. At t equal to 1, this function g will have the value 1, but the function f will have the value 0.01 itself. It will be somewhere over here. So now it is easy to visualize that the graph of function f will be below this line like this up to this point, and there they will intersect, after which it will start growing sharply this way. So this is how we will have the graph. Let us make it in a better way. After intersecting the function g at this point, then it will grow like this straight. So this is our g of t, the straight line, and this is our f of t, which is the curve. So now we can clearly see that up to t equal to 400, the function g of t is greater than f of t. At 400 both are equal, and after that, after 400, we can see f is above g. This is our function f, this is our function g. So after 400, f of t is greater than g of t till infinity. So now let's check the options. First is saying for some t greater than 0, g is greater than f. Yes, in this particular portion from 0 till 400, g is always greater than f. So it is true. Then second is saying there exists a time t such that f of t is greater than g of t for all values of t greater than that. So yes, we have one such time. that is 400, because after 400 always f stays greater than g. Our f grows exponentially after that because it is a quadratic function, not exponentially, but it grows at a faster rate than g, which is a linear function itself, and f of t is a polynomial function actually. So yes, f is greater than t for all values greater than 400. So this is also true. And hence we'll be going with option C, that both statements 1 and 2 are correct. So that is the right choice. In this question, we have been given these 4 statements which will together form a logical sequence. They have been shuffled and we need to arrange them in a proper sequence so that we get a meaningful statement out of it. So let us have a look. First one is saying that on the terrace, once on the terrace, on her way to the small room in the corner, she notices the man. So she notices a man. Let us highlight the highlight of the sentence. We have written it over here, and then let us see where does it fit in the sequence. Next is saying she begins to pant by the time she has climbed all the stairs. Now here they are talking about the terrace, and here she is climbing the stairs. So maybe she was climbing all the stairs to reach the terrace, and then after reaching on the terrace, she noticed this man. So maybe this statement will come before that. Climbing stairs, notices a man on terrace. This may be the sequence for these two. Then third one is saying she has brought vegetables and rice at the market, so her bags are heavy. Now it might be possible that she bought vegetables and rice from the market, her bags are very heavy, and this is the reason why while climbing the stairs she began to pant, which means she got tired by the time she reached at the top. So this statement might come even before. Brought vegetables, we can say, and then with her heavy bags she was climbing the stairs. Once she reached on the terrace, she noticed a man. Then the last one is he was leaning against the parapet watching the traffic below. Now this he might be the man whom she saw on the terrace. And what was he doing? He was watching the traffic. So that might come at the end. This can be the possible sequence, that she brought vegetables from the market, her bags were heavy, she was climbing stairs with those heavy bags, and hence she was panting. Once she reached on the top, on the terrace, she there noticed a man, and that man was watching traffic. This could be the possible sequence. So let's number the statements. Brought vegetables, that is the third statement. Then she was climbing stairs, it is the second one. She notices a man, that is first. And finally, the man was watching traffic, that is the fourth statement. So what is the order that we got? 3, 2, 1, 4. This should be the correct sequence, and it has been given in the last option, 3, 2, 1, and 4. So we'll be going with option D. In this question, we have two functions, f of x and g of y, in terms of x and y respectively, such that f of x is equal to g of y for all the real values of x and y. What does it imply? That whatever the value of x I randomly select from the set of real numbers and I put over here, similarly whatever the random value of y we are putting over here, both the functions will always give the same value, which means if I take f of 5 and here I take g of 1000, they'll be same. I'm taking f of minus infinity, g of plus infinity, they will again be same. Similarly, f of 0, g of 0, or anything, they will always be same. It is not necessary that we take the same parameter. Like here we had 0 and 0. Need not. 5 and 1000, they are still same. So what is it implying? Whatever x I take, whatever y I take, they're always same. So now let us say I'm taking f of a and f of b. Will these both be same? We cannot directly comment just by looking at f, but let us take some g of c as well. So now I can definitely say that f of a and g of c is same, because that is what is implying by this particular statement. Similarly, f of b and g of c will be same, and this ultimately implies that f of a and f of b will always be same for all a and b, which means f of x is a constant. Whatever x I take, it is always going to take the same value. And in the same way, if I have g of a, g of b and f of c, by the same logic I will say that this g is also a constant function. G of y is also a constant, and both of these constants are same. That is why for every x and for every y, they are always equal. So both of these are actually constant functions. Can we say that they are equal functions as well? Yes, because for every value, they are giving the same result, and that is a constant. So now let us check the options and see which of them suits the best. First one is saying f of x is 0, g of y is 0. Now this may not be true because the constant can be anything. What we actually have is f of x equal to g of y equal to some c. That c can be anything, it need not be 0. So this is incorrect. Next, this is what we have got. For every x, for every y, both the functions will always give the same constant value. That is true. Next, f is not constant, g is not constant. No, both of them are constant functions. Lastly, f plus g equal to f minus g. Okay, now let's visualize this one. It seems that it has to be true, but how actually it gets implied? See, this is what we have got. Now f plus g, what will it be? C plus c, and means 2 times the constant value, or you can say some other constant value, say k. And this f minus g, if both are the same constant function, then c minus c, it will give 0. So yes, now k is also a constant, 0 is also a constant, but both are different. Both the sides, f plus g and f minus g, are giving us constant values, but both the constants are different. So we cannot say that this is true as well. So we'll simply be going with the option B, because D was anyway, it was trying to be an implication of this B itself. And anyway, that is incorrect. So we will definitely say that option B is the correct answer, and both of them are constant functions. This is a spatial aptitude question about figure transformations. We have been given this figure P initially, which in one operation will get converted to figure Q, and then from this figure Q, by applying one more operation to this, it will finally get converted to figure R. So what we basically need to do is we'll determine what are these operations 1 and 2 that will help us achieve this particular task. So now let us first have a look at these figures P and Q. You can see that this, the longest leg of the star, it has turned over here. So you can see that it is not exactly opposite, it has come some way like this. So like it has been rotated by 90 degree, that can be seen. And if you also check for the other legs of the star, this is the second largest edge and that has come over here. So again, that is a 90 degree. So we can say that if we turn this figure P by 90 degrees to the right, then we will get this figure Q. So let us see if that's there in any of the options. The first one is saying a clockwise rotation by 90 degree about an axis perpendicular to the plane of the figure, which means from the same axis we simply flip this 90 degrees to the right, then we'll get figure Q. So this seems to be the correct operation. It has also been given in the C option, the clockwise rotation by 90 degree. B is discarded because it is saying counterclockwise, and D is discarded because it is saying 180 degree rotation. So now we are left with just two options. And next let us move on to check this operation 2, that how we can convert figure Q into figure R. So here we can see the longest leg, it is pointing to the southeast direction in Q, while if we check in R, it seems to be pointing to the northeast direction. So again it seems like that there is a 90-degree rotation and anti-clockwise this time. But if that were the case, then P and R should have been the same, because first we are rotating 90-degree clockwise, then we rotate 90-degree anti-clockwise, then this Q should again convert into P, right? But we can see that P and R are not the same, which means there is no 90-degree rotation over here. Operation 2 is not a counterclockwise rotation of 90 degree. Something else has been done. Okay, so for that let us check other legs over here. This is the second largest leg of the star, and that has now come to this particular position. So for this one also we can see that initially northwest, then southwest. So again it seems to be 90-degree rotation anti-clockwise. We'll also check for the other legs. This is the shortest one, the tiniest leg of the star, and that is now come to this place. So now what operation this could be? It seems that the original, this one, which was along the horizontal axis, that is staying at the same position. It has not rotated by 90 degree anywhere. So looking at this, what comes to my mind is it might be possible that there might be a horizontal axis like this, and what they did is they simply flipped the figure upside down, either like this or like this. Then only it will happen that this particular leg will stay in the same position and others will swap their places upside down. This was initially downwards, now it turned up. This second largest leg was initially upwards, now it came downwards. So yes, this is a possible operation, that there was a horizontal axis and they simply flipped the figure upside down. Let's check the option. Reflection along the horizontal line. Yes, that is what we were talking about. Flipping along a horizontal axis. Option C is saying reflection along a vertical line. No. If it were vertical, then this would have come on this side. The tallest leg would have come on the opposite side. That is not the case. They have taken the reflection along horizontal axis itself. So we will go with option A as the correct answer.
This question belongs to compiler design subject and was asked in GATE CSE 2023. So the question states, consider the following statements regarding the front end and back end of a compiler. The front end includes phases that are independent of target hardware. The back end includes phases that are specified to a target hardware. The back end includes phases that are specific to a programming language used in source code. Identify the correct option. Only S1 is true. Only S1 and S2 are true. S1, S2, S3 are all true. Only S1 and S3 are true. So what is a compiler? Compiler basically takes our high level language and converts it to assembly level language. So what are the phases of compiler? So first of all we have lexical analysis, then we have syntax analysis, then we have semantic analysis, then we have intermediate code generation, then we have code optimization, then we have target code generation. Code generation. All of them are using symbol table and error handler. Symbol error handler is basically used to handle the errors during any phase, and symbol table consists of what are the various symbols used. It is a map of those symbols. We are given a high level language as an input and we get an assembly level language as an output. See, what we do in lexical analysis phase, we match the lexemes with patterns to generate the tokens. Then here we do the syntax verify the, here we check for semantic error, here we check for syntax error. Then we convert it into intermediate code like 3 address code or directed acyclic graph. So all these parts are basically called front end. Why they are called front end? Because they are independent of hardware. Like whatever with the underlying hardware, all these steps will remain the same. And we can take the front end of a compiler and we can basically apply the back end in different types of hardware. Like we can do this part in one machine and the rest part in another machine. But this is called the back end of compiler, the code optimization, target code generation. Or you can also call the first one as the analysis part of compiler, and this is the synthesis part of compilation. Backend. Why it is called backend? Because it is hardware dependent. All these statements, because there are some code optimization statements that depend on the hardware, and this is target code generation is entirely hardware dependent. Like what are the instructions given to us, like mov, mcp, certain instructions depend on the hardware. So let us see the options. The front end includes phases that are independent of the target hardware. Yes, front end is independent of the hardware. The back end includes the phases that are specific to the target hardware. Yes. The backend includes phases that are specific to the programming language used in the source code. No, not specific to the programming language, specific to the hardware. So answer is only S1 and S2 are true. Option B. This question belongs to data structure subject and was asked in GATE CSE 2023. So the question states, consider which one of the following sequences when stored in an array at locations A1 to A10 forms a max heap. So we have an array over here with the elements like this, and we need to tell which of them follows a max heap. So max heap has a property that a node value should be greater than all its children, whether it's left subtree or its right subtree. So let us store these values. So we have 23, then 17. These will be stored directly. Level order storing would be there, as default for max heap is level order. 13, 14, 1, 5, 7, 12. So let us see whether it's form max heap or not. 23 should be greater than all. Yes. 17 should be greater than all. 10 should be greater than all. No. But 10 is less than 14. So our option A is false. Then we have 23, 17, 14, 7, 13, 10, 1, 5, 6 and 12. 23 should be greater than all. Yes. 17 should be greater than all. 14 should be greater than all. 7 should be greater than all. 13 should be greater than all. 5 and 6. Yes, this follows the max heap property. Let us see option C. So option C is, let me draw it for you. So option C is 23, 17, 14, 6, 13, 10, 1, 5, 7, 15. So 23 should be greater than all. Yes. 17 should be greater than all its below. Yes. 14 should be greater than all. 6 should be greater than all, but 6 is less than 7. So it fails max heap property. Fourth option, 23, 14, 17, 1, 10, 13, 16, 12, 7, 5. So 23 should be greater than all. Yes. 14 should be greater than all. Yes. 17 should be greater than all. Yes. 1 should be greater than all its left and right subtree, but 1 is less than 12 and 7 both. So option D is also false. So answer is option B is correct. This question belongs to data structure subject and was asked in GATE CSE 2023. So the question states, let SLL-DLL be a function that deletes a node in a single linked list, given a pointer to the node and a pointer to the head of the list. Similarly, let SLL-DEL We have another function that deletes the node in a doubly linked list given a pointer to the node and a pointer to the head of the list. Let n denote the number of nodes in each of the linked list. Which one of the following choices is true about the worst case time complexity of SLL and DLL? Okay, deletion. So here SLL DEL is order of 1 and DLL DEL is order of n. Both are order of log n. Both are order of 1. SLL is order of n and DLL is order of n. So let us see. Here we have been given a linked list with a no value and a pointer pointing to the next. So this is our linked list. Here null will be there. We will have some addresses like 1000, 2000, 3000, 4000. We will have some values like v1, v2, v3 and v4. We will have a pointer to this by head, and let us suppose we have node n1 and node n2, and we want to delete this node n1. So what can be the worst case complexity? So worst case can be this n1, we can have a node like this, and this n1 can be present at the end of the node or the second last of the node. So what we need to do? We need to traverse from start and reach before n1, the node before n1, and once we reach there, we will make this link point to the node next to n1. So we will do something like n1, let us rename this as n. So we will do n dot next equals to n1 dot next. So this link will point over here, and then we will do free n1. So this will remove this link. In worst case, it can be present at the end. So first we need to go to the node before n1 so that we can change its link to the node after n1. So its complexity would be order of n. So first one is order of n, which is SLL DEL. Let us see the second one. So what is the second one? Here we need to delete a node in a doubly linked list. Okay, so if we have a doubly linked list, so what will be the complexity? So let me draw a linked list for you. Let us take the linked list to be something like this. Okay, you can have backlinks as well, as it is a doubly linked list. You will have values like v1, v2, v3, v4 and v5. All of them would be having some address like 1000, 2000, 3000, 4000 and 5000. Let us suppose we want to delete this node. So what we need to do be another function that deletes a node in a doubly linked list. Okay, so let us suppose we want to delete, we have n1, n2 and n3, and we want to delete n2 in a doubly linked list, and we are giving a pointer to this as well as to this. So how will we delete this? If we are given 3000 address, so we can go back of 3000 to n1, and then we can do n1 next, n1 dot next equals to n2 dot next. So this will point to over here. Okay, now what we can do? We can do n3 dot, we can do n2 dot next dot previous equals to n2 dot previous. So what it will do, n2 dot next, which is n3 previous, it will make it point to n2 dot previous, which is n1. And here, instead of directly n1 dot next, we can do n2 dot previous dot next. So it will, what it will do, let me show you with the correctly. So first of all, you will directly have n2. So we will come over here. We will do n2 dot previous, which is n1. n1 dot next equals to n2 dot next. So n1 dot next will now point to n2 dot next. Okay. Then we will do n2 dot next. But we'll have this n2 dot next still. So n2 dot next, which is n3. n3 dot previous, which is this one, it will make it point to n2 dot previous, n2 dot previous, which is this. Now we will free it. So free will remove this link as well as this link. So we will have free n2. So the complexity for this is order of 1. So second one DLL takes order of 1 and first one takes order of n. So answer is order of n and order of 1, option D. Some of you might think that the first one can also be done in order of 1. Let me show you how. But it's not true. Let us analyze it once. So if we have some links over here, like this one, this one, this one, and this one. So some of you might give a counter argument that if you want to delete n2, then do one thing. You have this 3000 address, you have this 1000 address. Then go to next of 3000 and swap these two values. So you swap, make v4 over here and v3 over here. Okay. Now you know this n2 address. Now make n2 next, point to n3 next, and then remove this one. It's basically a feasible solution, but the problem here is that vi, these values, you do not know what these values are and how much time will it need to take to swap these values. If it is given that they can be swapped in order of 1, then definitely first one can also be done in order of 1 SLL. But as nothing is given about the values, thus we will assume it to be order of n. So answer is option D, order of n and order of 1 respectively. This question belongs to Theory of Computation subject and was asked in GATE CSC 2023. So the question states, consider the deterministic finite automata DFA A given below. The DFA runs on the alphabet 0, 1 and has the set of states S, P, Q and R, with S being the start state and P being the only final state. Which one of the following regular expression correctly describes the language accepted by A? So here see, this state R is not reachable from initial state. Okay, and even if we come over here, we can't go out. So we can write this DFA equivalent to, we can write the NFA like P, we can remove the trap state 1, Q, 1 over here. Okay, now see, we are having a 1, so 1 will come. Now we can loop anytime 0 or we can go to this 1, 1 path. If we have two options on a path, if we have A and B, then we just write A plus B whole star, which means we can have any number of A's and any number of B's. So if we try to merge this Q state, then it will reduce to S, P being a final state, 1, 0. We can write a 1, 1 loop over here. And then it will get reduced to 1 followed by 0 or 1, 1 whole star. So answer is 1 followed by 0 or 1, 1 whole star. Let us also try to remove all the options. Here, what is this? Here we have 1, 0 star, 1, 1 whole star. So can you generate something like 1 and 0 from this? No, you can't generate 1, 0, but 1, 0 is being accepted as you will have a 1. But if you take a 0, then 1 will come with it. So answer A is false. 0. If we take this as null, then 0 should get accepted, but 0 is shouldn't get accepted. So this is false. For this one, can you have something like 1, 0? You can't have 1, 0 only, as if you want to take 0, you need to also take 1, 1. So correct answer is option C is true. This question belongs to engineering mathematics subject and was asked in GATE CSC 2023. So the question states, the Lucas sequence L of n is defined by the recurrence relation. L of n equals to L of n minus 1 plus L of n minus 2 for n is greater than or equal to 3, with L1 equals to 1 and L of 2 equals to 3. Which one of the following options given is true? So these are the options. You can do this question by these boundary conditions only. Always try to first satisfy the boundary condition. So let us check for L of 1 equals to 1. Let us put n equals to 1. So here we have 1 plus root 5 by 2 plus 1 minus root 5 by 2. So root 5 and root 5 will cancel and we will get 2 by 2, which is 1. Okay. Let us put n equals to 3. So for n equals to 3, here we have, let us first check all for 1s. This one satisfied for 1. For this one, we have 1 plus root 5 by 2 minus 1 minus root 5 by 3. So we have LCM as 6, 2, 3 root 5, 3 into 2 minus 2 minus 2 root 5. So here we have 3 minus 2, 1 plus 3 root 5 plus 2 root 5 plus 5 root 5 by 6. So this is wrong, as it is not satisfying for n equals to 1. Let us see option C. So option C is 1 plus root 5 by 2 for n equals to 1 plus 1 minus root 5 by 3. So LCM is 6. Here we have 3 plus 3 root 5 plus 2 minus 2 root 5. So 3 root 5 plus 3 plus 2 is 5. 3 minus 2 is 5 plus root 5 by 6. So this is also not satisfying. Let us see for option D. You can easily do these questions by checking options only in most of the time. So option D for n equals to 1 is 1 plus root 5 by 2 minus 1 plus root 5 by 2. So root 5 plus root 5 is, this one get cancelled. We have 2 root 5 by 2. So by n equals to 1 only you can find out easily, as here everything will get cancelled out. Okay. Let us verify it for the first option for n equals to 2. So here we have 1 plus root 5 by 2 whole square plus 1 minus root 5 by 2 whole square. So what is a square plus b square? So we have a square plus b square plus 2 root 5 by 2 plus a square plus b square. B square is 5 minus 2ab minus 2 root 5. This is 2 square, 4. 4 will come as common. We will have 5 plus 1, 6 plus 6 plus 6, 12. And this will get cancelled out, 12 by 4, which is 3. So answer is option A. You can easily do this by these boundary conditions only. This question belongs to database management subject and was asked in GATE CSE 2023. So the question states, which one of the following options given below refers to the arity or degree of a relation in a relational database systems? Number of attributes in this relational schema, number of tuples stored in the relation, number of entries in the relation, number of distinct domains of this relational schema. So let us see some definitions. Let us suppose we are storing the information of a student. So what can we have? We can have its registration number, we can have name of student, and we can have section of student. We can have some entries like registration number 101, 102 and 103, name as A, B and C, section as S1, S1 and S2. So what is a relation? A relation is basically a collection of rows and columns. So these are columns and these are rows. So this entire thing is a relation or a table. What is a particular entry called? A particular entry is called the tuple. And what is a particular column called? A particular column name is called an attribute. So it has 3 attributes: section, name and registration number. And this is a particular tuple. And the number of tuples is called the cardinality of this relational table. And the number of attributes is called the degree or arity. So arity here is 3, and if we have another entry like 104D and S2, then cardinality is 4. So question is asking about degree. So degree is equal to number of attributes of this relational schema. This is the degree. So answer is option A. This question belongs to computer network subject and was asked in GATE CSE 2023. So the question states, suppose two hosts are connected by a point-to-point link. So we have two hosts connected by a point-to-point link and are configured using stop and wait protocol. For reliable data transfer, identify in which one of the following scenarios the utilization of link is the lowest, which means efficiency is the lowest. Longer link length and lower transmission rate, longer link length and higher transmission rate, shorter link length and lower transmission rate, shorter link length and higher transmission rate. Okay, so first of all, let us briefly analyze stop and wait. So in stop and wait, if we have a packet, then we basically first transmit the packet by using TT, which is transmission time. Then the packet propagates using TP time, which is propagation time, to the receiver, and then the acknowledgement comes back using TP time. And then after getting the acknowledgement, we send another packet, which is TT, by taking TT time. So this is stop and wait, as we stop and wait for the acknowledgement. So how many packets are we sending in? So how many packets can we send in this window? So total window is TT plus 2TP. How many packets can we send? As each packet is basically taking our TT time to get propagated. then we can send 1 plus 2 TP by TT packet in this total time, and let us call this factor as A. A equals to TP by TT. So we can send 1 plus 2A packets, but how many are we sending? Efficiency equals to what work we are doing and what work we can do. So we can do 1 plus 2A work, but we are sending only one packet. So one packet equals to, we are sending only one packet. So the efficiency equals to 1 upon 1 plus 2A. Now let us expand this. Efficiency equals to 1 upon 1 plus 2A. A, what is A? A is TP by TT. Let us expand it more. 1 upon 1 plus 2. What is TP? TP equals to distance, which is link length, upon speed. And what is TT? TT is length of packet. Length of packet. Packet divided by bandwidth. Okay. Now let us see the options. So it is asking about the link length. So this is the link length and this is the transmission rate. Okay. So we can see efficiency is inversely proportional to them. So to reduce the efficiency, we must both increase the link length as well as the transmission rate. So answer is longer link length and higher transmission rate. Here, make sure that we have assumed the transmission rate, as it is asking identify which one of the following the utilization of the link is lowest. Here we have assumed transmission rate equals to bandwidth. There is another definition where transmission rate can also be equals to our, see, what is efficiency? Efficiency equals to throughput into bandwidth. So transmission rate can also be assumed to be throughput. If we assume transmission rate to be equals to throughput, then you can see efficiency equals to throughput upon bandwidth. Then we need to basically, to reduce the efficiency, we must reduce the throughput. So we will have longer link length and lower transmission rate. If we So we have the second option if we assume that transmission rate equals to bandwidth, and we have first option if we assume transmission rate equals to throughput. But most probably answer would be B only, as transmission rate is our bandwidth. But if it was given that transmission rate equals to throughput, then answer had been option A. This question belongs to engineering mathematics subject and was asked in GATE CSE 2023. So the question states, let DET A and DET B denote the determinants of the matrices A and B respectively. Then which one of the following options given below is true? Determinant of A equals to determinant of B, determinant of B equals to minus determinant of A, determinant of A equals to 0, and determinant of AB equals to determinant of A plus determinant of B. Okay, so let us see the values. Here you can see 4123 is common in both of them and 2341 is common in both of them. Okay, so what we have done, we have just interchanged the row 1 and row 3, and determinant of A can be converted to determinant of B by interchanging row 1 and row 3. Okay, so this is a row operation. There is an identity that if we have a matrix M and if we change one row or one column, then the determinant of, and it gets converted into N, then determinant of N is equals to minus 1 into determinant of M. We can easily prove this by taking a small example. Let us suppose we have something like A, B, C and D, and then we change, this is our M, and then we convert it into N by changing the rows and columns to C, D, A and B. So what is its determinant? Its determinant is AD minus CB. What is N determinant? N determinant is equals to CB minus AD. We can take minus as common, we will get minus of CB plus AD, or we can write it as minus of AD minus CB. So here we can see determinant of N is equals to minus determinant of M. So on changing a single row, determinant gets multiplied by 1. So here the correct answer is determinant of B is equals to minus determinant of A. It's a standard property of determinant. So answer is option B. This question belongs to algorithm subject and was asked in GATE CSE 2023. So the question states, consider the following definition of a lexical token ID for an identifier in a programming language using extended regular expressions. So letter can either be from capital A to Z or from small a to Z. Digit can be in the range 0 to 9. And this is the regular expression for a ID. It's letter followed by letter plus digit whole star. We can also write it as letter followed by either letter plus digit whole star. Clean closure. Which of the following DFA, non-deterministic finite automata, means NFA with null epsilon transitions accepts a set of valid identifiers? A double circle denotes a final state. So we need to tell what is the NFA for this regular expression, NFA with epsilon transitions. Okay, let us see what this one accepts. See, this language should accept letter followed by anything. Letter followed by even null will be fine. But here, nothing, which means null will also get accepted. As on starting state using epsilon transition, we will reach final state and then we can accept null. Thus, option A is false. Let us see option B. Here we are having letter, then on epsilon transition we are moving to this state and we are accepting any number of letters, fine. Or we can accept any number of digits, okay. But things like letter, digit, letter won't get accepted. As on seeing a letter we will come to this state, then on epsilon transition we will come over here, or even if we come over here we will accept a digit but we will remain here only and there is no transition on letter over here. Thus it will not accept this. Thus, option B is also false. Let us see option D. It accepts letter, then another letter. Okay, but on seeing another letter, we come to a non-final state. So things like letter won't get accepted. Okay, and things also like letter digit won't get accepted as there is no transaction on digit from this state. Okay, so it will also fail for letter or letter digit. So option D is also false. Let us see option C. Is null getting accepted? No, null is not getting accepted. It's perfect. On seeing a letter, we comes to a final state. Thus, letter is accepted. Then we go to two states, a letter state and a digit state. Here we can accept a letter, okay, and here we can accept a digit, okay. Thus, letter is accepted, and letter and digit is accepted. Can we have a digit after a letter? Yes, letter. Then we can come to over this state, and then we can accept another digit over here. Thus, everything of the form letter plus digit whole star is accepted by this NFA with epsilon transition. So answer is option C. This question belongs to algorithm subject and was asked in GATE CSE 2023. So the question states, an algorithm has to store several keys generated by an adversary in a hash table. So we have a hash table, and we need to store keys over here. The adversary is malicious, who is trying to maximize the number of collisions, which means it uses a function which maps to any one of the slots. And adversary is trying to maximize the collision, which means adversary is trying to make sure that this function always points to the same value, which means maximum keys points to the same value and thus maximum collision occurs. Let k be the number of keys, m be the number of slots in the hash table, and k is greater than m. Which one of the following is best hashing strategy to counteract the adversary? Division method, i.e. using the hash function h of k equals to k mod m. Multiplication method, i.e. hash function h of k equals to floor of m of ka minus floor of ka, where a is a carefully chosen constant. Universal hashing method, and if k is a prime number, use division method, otherwise use multiplication method. See, here you can see various functions are given, but you can see these functions are irrelevant unless we are given the actual function and the actual keys. Unless we are given the keys. If we would have been given the keys, we would have applied all the functions and found out which gives the minimum collision. But here keys are not given. Thus we have to go by definition. The answer is universal hashing method. And see, I will be showing you this comment. This is taken from the Wikipedia page. What is a universal hashing? So in mathematics, a universal hashing, in mathematics and computing, let me first increase the font so that you can easily see what's written over here. See, okay. So in mathematics and computing, universal hashing in a randomized algorithm or data structures refers to selecting a hash function at a random from a family of hash functions. So we have infinite hash functions, a family of hash functions. So universal hashing refers to selecting a hash function out of that family with a certain mathematical property. that guarantees a lower number of collisions in expectation even if data is chosen by adversary. So it's basically the question is just asking what's the definition for a universal hash function. So we are using a mathematical function to choose a hash function out of a family which guarantees the minimum collision. So universal hash function internally guarantees the minimum collision based on mathematical functions. So answer is option C. This question belongs to digital logic subject and was asked in GATE CSE 2023. So the question states, the output of a two-input multiplexer is connected back to one of its input as shown in the figure. Match the following equivalence of this circuit to one of the following options: D flip-flop, D latch, half adder or demultiplexer. See here, here we have the select line and two inputs 0 and 1. Let us name this as I0 and I1. So I0 is equals to the output, which is Q. So I0 is equals to Q and I1 equals to the input. Let us name this as X. So I1 equals to X. So what is the table for a multiplexer? So if we have a select line, then the output Q. If the select line is 0, then we are getting I0 as output. If the select line is 1, then we are getting I1 in the output. So Q plus, which is the next state, can be written as S complement I0 plus S I1. Now let us see the conditions when S equals to 0. When S equals to 0, then Q plus equals to 0 complement I0 plus 0 into I1. 0 complement is 1, 1 into I0 plus 0. So it equals to I0. And what is I0 equal to? I0 is equals to Q, which is the previous output. Thus, this is the memory state. Memory state means previous output is retained. Now what happens for S equals to 1? There Q plus equals to 1 complement I0 plus 1 into I1. So 1 complement equals to 0 into I0 plus I1. So Q plus equals to our X. Q plus equals to I1, which equals to X. So here we have got Q plus equals to X, which means output equals to the input. As here you can see that either we can have a D flip-flop or a D latch. So a D latch is level triggered and D flip-flop is an edge triggered. Here you can see that on S equals to 0 and S equals to 1, this S is basically acting as a clock. This S is basically acting as a clock. And on 0 to 1, it's changing the output. Thus, it is level triggered. And on 0, it is having a memory state. Thus, answer is D latch, option B. This question belongs to operating system subject and was asked in GATE CSE 2023. So the question states, which one or more of the following need to be saved on a context switch from one thread T1 of a process to another thread T2 of same process? Page table base register, stack pointer, program counter, or general purpose register. It is an MSQ type question. So let us see what is the meaning of context switch. Suppose we have CPU and CPU is running a particular process, a thread T1 of a process P1. This one means thread number and this means process number, and this means thread number of a process. Okay. Now when executing, it will have its own code. Now suppose it got preempted and another thread T21 wants to execute, maybe because of higher priority or because of some scheduling algo, then we need to basically save some information of T11 so that when T11 resumes its execution, then we can resume from the same point, or we can basically recreate the same scenario again. So that saving of information is called context switching. That information is called context and saving of information is called context switching. So see, let me show you what a context looks like. So we have a thread control block for this. So here we will be saving the thread ID. What is the ID of this thread? What is its current state? what is its program counter, register contents, what is its priority, pointer to process that created this thread, and pointer to other threads that were created by this thread. So here, let us see each of the options. So what is page table base register? So for each thread, we will be having a page table, and this page table starting address is stored in page table base register. So suppose we were executing T11 and now we want to execute T12. So do we need to store page table base register or not? As it is given, it is replaced by another thread of same process. Here we do not need to basically store page table base register. Why? Because all the threads of a process have the same page table. So they will have the same page table base register. So there is no point of storing the page table base register, as each thread will have the same PTBR value. Stack pointer. So stack pointer basically points to the top of the stack. Each thread will be having its own stack. So thus we need to make sure that we store this stack pointer in a particular register so that it can be restored when T11 resumes its execution. What is program counter? Suppose we have code like this and this code got executed till this point. So program counter stores the address of next instruction to be executed. Now if we want to resume T11 again, then we need to know where we left it. So that point address is basically stored in program counter. Thus we need to basically store this program counter too, so that we can resume the T11 execution again from the same point. General purpose registers. Yes, we need to store the general purpose registers. So what is the general purpose register? So suppose we were performing some computation. So there may be some intermediate values which are stored in some registers. Some temporary values may be stored in registers. So these temporary values may be needed further in the computation. Like suppose we may have stored some value in R1 and R2, and we may be using R1 and R2 value later on. So as to maintain the integrity of the register value, they need to be stored, as a thread might come and change the R1 and R2 value, and we will lose the value. So if we do not want to lose the value, we need to store the value. Thus option B, C and D are correct. This question belongs to operating system subject and was asked in GATE CSE 2023. So the question states, which one or more, which means it is an MSQ question, of the following options guarantee that a computer system will transition from user mode to kernel mode? Function call, malloc call, page fault or system call. Let us see what is this user mode and kernel mode. So basically there are two modes of operation in which our computer can work. We have user mode and kernel mode. Okay, so whenever we want to do any work that has some security, that needs some security, then we are using kernel mode, and for other works we can use the user mode, and it is basically indicated by a mode bit. We have a mode bit, it can have a value 1 or 0. One of them is assigned for user mode and another is assigned for the kernel mode. Okay, so, and what is a system call? Whenever we want to get any service from the operating system, then for each service there is an assigned system call. We use system call to get any type of service from the operating system. Okay, so for a system call, there we will need some security. Thus, we will transition from user mode to kernel mode. Okay, and what is a page fault? Suppose we have our RAM over here and we have some physical memory. Not physical memory, we have some virtual memory with all the pages over here and all the frames over here. A page fault means a particular page was not present. So thus we will basically raise a call to the operating system and ask the operating system to search in the virtual memory for that particular page and bring it to a RAM. So it basically needs high level of security. Thus page fault will also need a transition from user mode to kernel mode. Malloc call. So what is a malloc call? So malloc is basically used for dynamic memory allocation. Like if we are allocating a memory for a linked list, then we basically need some node now, and for that node we will need some bytes of memory, and it is done by using malloc and calloc calls. So for malloc, it will directly check in its suppose malloc is managing this memory. It will directly check which memory is free and which is empty without the need of system call. Here system call is not needed for malloc. So as system call is not needed, just security is not needed, and there is no need of transitioning from user mode to kernel mode. So functional call, so malloc is false. And what is a function call? For a function call, there is no need to transition from user mode to kernel mode, as function calls do not need much security. Thus answer is page fault and system call. So answer is option C and D. This question belongs to theory of computational subject and was asked in GATE CSE 2023. So the question states, which of the following statements is correct? So it is an MSQ based question. Options are: the intersection of two regular language is regular, the intersection of two context-free language is context-free, the intersection of two recursive language is recursive, the intersection of two recursively enumerable language is recursively enumerable. So for these type of questions, just remember this table. It has operations union, intersection, complement, concatenation, Q star. All these are important, and this one is important. Intersection with regular language and reversal too. You can also learn other two, but these union, intersection, complement, concatenation, star, reverse, and intersection with regular language. These 7 are the most important. So let us see. The intersection of two regular languages is regular. So regular language intersection, yes, it is regular. The intersection of two context-free languages is context-free. So under context-free row, context intersection column, it is no. So what does this no means? This no means if we have two languages, CFL1 and CFL2, then their intersection may be regular or may not be regular. There is no certainty. It can also may or may not be CFLs. So there is no certainty. It may be a CFL or it may not be a CFL. Thus it is false, as there is no certainty and it is asking for certainty. The intersection of two recursive language is recursive, yes, always. The intersection of two RE languages is RE. RE language means recursively enumerable. The intersection, yes, it is always RE. So just remember this table and you can answer most of the questions. So answer is option A, C and D are correct. This question belongs to computer network subject and was asked in GATE CSE 2023. So the question states, which one of the following statements is incorrect about the OSPF, Open Shortest Path First Routing Protocol used in Internet? OSPF implements Bellman-Ford algorithm to find shortest path. OSPF uses Dijkstra algorithm to find the least cost path routing. OSPF is an inter-domain routing protocol. OSPF implements hierarchical routing. So let us see what is routing. So what we are doing, we have in the internet we have various routers. So we basically divide it into various areas. These areas are called autonomous systems. So we have various autonomous systems: autonomous system 1, autonomous system 2 and autonomous system n. And various routers are present inside an autonomous system. Now there can be two types of routing: inter-domain router or intra-domain routing. If we are sending a packet from a router A to B, then it is within an autonomous system. So it is called an intra-domain routing. Okay. And if we are sending it from router A to router C, then it is between two autonomous systems. So it is called inter-domain routing. Now this intra-domain routing can be of two types. Either it can be done of routing information protocol or open shortest path first. This routing information protocol uses distance vector routing and OSPF uses link state routing. Here we gather information about all the routers. Here we gather information only about adjacent routers. It uses Bellman-Ford algorithm and this one uses Dijkstra's algorithm. So let us see the options. Here option A says OSPF implements Bellman-Ford algorithms. No, OSPF implements Dijkstra algorithm. So this is false. OSPF uses Dijkstra shortest path. Yes, this is true. OSPF is an inter-domain routing. No, it is an intra-domain routing. So this is false. Now let us see the option D. So for this, you basically need to refer to the diagram of OSPF. So in OSPF, we are basically divided into various autonomous systems. And here, this area 0 is the main autonomous system, or we can see the root. So here we can easily see that this one basically follows the hierarchical routing, as we have area 0. Area 0 is basically the root. And you can also refer to this link. Here you can get to know that OSPF implements hierarchical routing. So this is also true. So the question is asking incorrect ones. So incorrect ones are option A is false and option C is false. The rest all are true. This question belongs to engineering mathematics subject and was asked in GATE CSE 2023. So the question states, Gita has a conjecture about integers which is of the form. So this is the conjecture. It is for all x, px implies negation of y, qxy, where p is a statement of integers and q is a statement about a pair of integers. So for p we just have integers and q is a pair of x, y. Which of the following, one or more options, so it is a MSQ type question, would imply Gita's conjecture? So we need to tell which of the options, let us suppose either A or B or C or D will imply, let us suppose this is S. So which one will imply S? We need to tell this, either A, B, C or D. Or more than one can also be there. So let us see. Here we have been given that P is a statement about integers and Q is a statement about pair of integers. So which means x comma y belongs to pair of integers which can range from minus infinite, minus 2, minus 1, 0, 1, 2, 3 up till infinite. Now let us see what is the meaning of for all x. Here we have for all x px. So what is the meaning of this? It means for every possible value of x over this range of integers, px is true, which means it is equivalent to p1 is true, as it is true for all possible values. Thus it is true for p1, true for p2, true for p3, and so on. Also in the negative side and the positive side. And what is the meaning of if someone says there exists an x such that px is true? Then it means over the possible range, it is either at least true for one, which means either true for p1 or p2 or p3, or can be true for more than one, like it can be true for p1 and p3 but not p2. But we have used an or, which implies that if it is true for any one of them, then this statement will become true. Now see what S implies. So S says for all x, px implies there exists an y such that qxy is true. Okay. So can we break down x into these ranges? Yes, we can break down. Which means p1 is true implies here x is 1. So here x should be 1. Which means q, let us take y as generic. We can take generic or we can also split about. This is true. As this is there exists, which means or will come. Q either 1, 2 is true or Q1, 3 is true and so on. So we have done for this there exists, and for this or for all we need to have and. So thus we will have and with another P2. So we will have P2 implies Q21 or Q22 or Q23 and so on, and we will have another and for all the possible ranges we will have. So it will keep on going. Now what we need to tell? We need to tell which of the following options implies our S. Okay. So if we need to tell like which of the options among, we need to tell whether this is a tautology or not. This implication is true which means this is a tautology. This is a tautology. Tautology means true for all values. True for all values. Okay. So now see, when a tautology is false, true for all values. So A implies, if we have x implies y, then it can be written as negation of x plus y, or we can write negation of x or y. Now, when is this true? Or we can say when is this false? So this is false only in the case when x is true and y is false. Okay, so let me write it over here. So when is x implies y false? X implies y is false when x is true and y is false, because negation of true will become false and or with false will remain as false. Okay, now what we need to do? So here what we will do is that we will try to make this statement s as false. So we will try to make this y part as false, which means statement s as false. Let me write it over. Make s as false. Okay, which means of this statement any one of them will be false. Okay, thus this entire s will be, see, this s is comprised of all these things. Let us write it as P1, this is P2. So S1 is P1 and P2 and P3 and P4. So if we want to make S as false, which means we need to make any one of the part as false. Okay, now see. So the conditions are like this. PA is true for at least one A, which means for C. Here we have and between the statements. Okay, so PA is true for at least one A. And QAB is false for all y corresponding to A from 1, where A and B comes from the domain. Okay, now let us see all the options one by one. See, we have option A. So what option A states? Option A states that there exists an x, px, and for all y, qxy. So we need to tell whether this implies S is a tautology or not. Now, how can we break this up? So, we know that there exists means either first part is true or second part is true or third part is true. This is the meaning of there exists, this one. So, we can break this up as, we can write the values for x. So, x can have one value and negation of y with q 1 comma y. Either this will be true or p2 and negation of y with q 2 comma y will be true, or, and this will keep on going. Okay, which means any one of them will be true. Now we can make this statement as true. How can we make this as true? We can make this as true by making p1 as true. We can make this as true, and for all y q1 comma y as false to satisfy the above conditions, and for other pc as true, and for all y qcy as true. So others will be, let, for all these others, first part will be true, and for all y qcy will be true, where c is not equal to 1. So the first part, this will be false and this will be true, and for the rest all of this will be true. So in this way above conditions will be satisfied and we are able to make the whole statement as true. Thus option A is wrong. As we are able to make the whole statement as true, thus it is wrong. So let me write over the conditions that we want to make sure. So conditions are, for at least one A, at least one A, PA must be true. PA must be true. This is the first condition. What is the second condition? QAB is false for all y. Okay, now A and B will come from the domain. So why we need to make these statements like this? We need to make them like this because we want to make SS false. So to make SS false, at least one of them must be true and QAB must be false for all of them. Thus if QAB is false for all of them, then this will be false and at least one of them will be true. Thus an entire thing will be false and all this S will be false. So this is the condition for making SS false. So if we are able to make SS false and the first part is true, then the entire thing won't imply. And here what we have done, we are able to make the whole part as true and S has been made false with these conditions. Thus this X implies Y will be false. Thus statement A is false. Now let us see option B. So what is option B? Option B states, let me write it over here. So option B states for all X, for all Y, QXY is true. Okay. Now see, how can we write this? We can write this as, we can expand X. So what all values it will take? For all Y, Q1 comma Y, and as it is for all, so it will have AND between the statements, and for all Y, Q2 comma Y, and for all Y, Q3 comma Y, and it will keep on going. So to make this statement as true, we need to make all of them as true. Okay. Now we can't make all of them as true because according to above condition 2, according to the second condition, QAB must be false for all B. QAB must be false for all B with at least one A, which makes the whole statement as false. But QAB is not, can't be made false to make this as true. Thus we can't have the first part as true and second part as false simultaneously. Thus option B is correct. Now let us see option C. So option C goes on like this. We have there exists Y for all X, Px implies Qx comma Y. Now how can we expand this? So we will have there exists Y forward and we can expand X. So it can have values P1 implies Q1 comma Y. Okay, we can have this, or we can have and, let me write it in brackets, and we can have, we are expanding X, so X can take second value. P2 implies Q2 comma Y. We are not expanding Y, we are only expanding X, and X value will keep on going. We are having and because of this for all, and we are having, and we haven't expanded this one. Okay, and we are having this there exist over here. Now let us see. Again, we can't make this entire statement true. Why? Because we can set P1 as true. We can make this one as true and this one as false. So if this is true and this is false, what is this statement? P implies Q. It's negation of true plus false, which means it's false plus false. So it will become false. So this entire statement will become false, and we have AND over here. This entire statement will become false. So we can't make it true, because we want to make at least one A is true and second one is false. So if we make it as true, then the statements become false. So thus we can't have this as true and this as false. Thus both can't happen simultaneously. Thus option C is also correct. Now let us see option D. So option D states there exists X, Px, and there exists Y, Qxy. Okay, so how can we expand this? Let us expand the same similarly, X, P1, and there exists Y, Qx comma Y, or P2 and there exists Y, Q2 comma Y, and so on. So this OR comes because of this there exist, and this AND is copied directly, and there exist is copied directly. Okay. So can we make this statement true? So for making this statement true, we need to make any one of the part true. So what we can do? We can make P1 as true, thus 1P is true, and this condition is satisfied, 1P is true. And we can make there exists Y, Q1 comma Y, we'll have Q1 comma Y as false. We can make this as false, which satisfies the given condition. And then we can make P2 as true, and this as true. And in this way whole statement will come true. So here we will have false, but this will be true. Okay, thus this statement will become true. So we will have this as true. So first part is true and second part is false. So true implies false is false, thus option D is also wrong. So how we have done this? Let me explain you once more. So answer is option B and C. So we have this statement. We need to tell which among A, B, C or D implies S. So when something will not imply when first part is true and second part is false. How can the second part be false? Second part can be false when we have all these conditions. So we need to make sure that all these conditions are satisfied, and if simultaneously while satisfying all these conditions we are able to make the first part as true. If first part can be true and all these conditions are satisfied, which means second part is false, then we can say that it doesn't imply. But if we can't have all these conditions are satisfied and first part as true can't happen, then this means this P A, B, C or D or that part implies S can't have true and false values, thus it will be a tautology. And this happened in case of options B and C. So answer is option B and C. This question belongs to operating system subject and was asked in GATE CSE 2023. The question states, which one of the following CPU scheduling algorithms can potentially cause starvation? First in, first out, round robin, priority or shortest job first? So first of all, let us understand what is the meaning of starvation. So starvation means indefinite waiting of a process. Waiting of a process. So what happens? Suppose we have a pool of processes and some new processes are being entered over here, and we have CPU, and CPU is selecting any one of the algos to schedule the process. Now suppose there is a particular process. First time it is denied as some other process is given priority over it. But starvation occurred when new process keeps on coming, and every time this process gets denied. If there is such a condition, then starvation will occur. So let us see all the options one by one. So we have first in, first out. Let us suppose process P1, P2, P3, P4 and P5 comes. Let us suppose then P2 wants to execute but suffers from starvation as P1 is executing. Do not suffer from starvation, has to wait as P1 is executing. It might execute in 100 years or 200 years, but it will definitely complete. When P1 completes, P2 will get a chance. Is there a possibility that a new process comes and gets scheduled before P2? No, as it is first in, first out. So there is no starvation. Let us see the second case. Second case is round robin. So what happens in round robin? Suppose we have some processes like this: P1, P2, P3 and P4. If this is the initial setup, then we have some time quantum. It can be anything: 100 year, 10 year, 10 second. Let's suppose 10 seconds. Then each process gets to execute for 10 seconds. Then again the first process gets, again all the process get executed for 10 seconds. So it's basically a preemptive algorithm where each process is given a chance. So is there a possibility of a starvation of a process? No, as whatever high with the time quantum, it is 100 years. If it is 100 years, then definitely there is a possibility that P2 has to wait for 100 years, but it will get a chance for sure. And can a new process P5 come and make sure that P2 doesn't get a chance? No. P5 can also take part in this process, but can't ensure that P2 do not get its chance. P2 will definitely get a chance. So round robin is also false. Now let us take the third one. Round robin also didn't suffer from starvation. Suppose we have a process pool. CPU is selecting from the pool based on the algo. Let us suppose we have 3 processes. This takes time 10 units, this takes 20 units, this takes 100 units. Okay. So what will happen? P1 will execute, then P2 will execute. Will P3 suffer from starvation? You may assume it will not suffer, but assume before P3 gets scheduled, another process P4 comes with 12 quantum. So P4 will get scheduled before P3. Now again after completion of P4, before P3 get execute, another process P5 comes with 13. So new processes may keep coming with lower time quantums, with lower burst time than 100. So they will keep on executing and P3 has to wait for indefinite time. So priority will suffer from starvation, as P3 might keep on waiting and new smaller processes might keep on coming. Let us see option 4. It is, so we have seen shortest job first, option 3. Now let us see priority. Suppose we have P1, P2 and P3 with some priorities like 1, 2 and 10. Lower number means higher priority. So P1 will get executed as higher priority, then P2 will get executed. Let us suppose before executing P3, another process comes, P4, with lesser priority like 5. Then P4 will get executed. Now assume another new process comes with priority 6. So P5 will get executed and P3 will keep on waiting till higher priority process will keep on coming. And it can happen for infinite time. Thus, priority will also suffer from starvation. So answer is option C and D, both will suffer from starvation. Priority scheduling and shortest job first. This question belongs to engineering mathematics subject and was asked in GATE CSE 2023. So the question states, let fx equals to x cube plus 15x square minus 33x minus 36 be a real valued function. Which of the following statements are true? So it is an MSQ type question. So option A is fx do not have a local maximum, fx has a local maximum, fx do not have a local minimum, fx has a local minimum. So it's a question related to maxima and minima. So let us see what is fx. Fx is 15x square x plus x cube minus 33x minus 36. So what is the first differentiation of fx with respect to x? It's 3x square plus 30x minus 33. Now let us put f dash x equals to 0. So 3x square plus 30x minus 33 equals to 0. So we can write it as 3x square plus 33x minus 3x minus 33 equals to 0. Let us take 3x as common. So we have x plus 11 minus 3 x plus 11 equals to 0. So what are the values of x? The values of x are 1 and minus 11. So let us find whether it has a maxima or minima. Okay. So what is the value of f double dash x? So what was f dash x? Let me see once. What was f dash x? Yeah. So f dash x was 3x square plus 30x minus 33. It was the first differentiation. Okay. So what is f double dash x? F double dash x is 6x plus 30. Okay, so what is the value of f double dash at 1? So we will have 36 value and it is greater than 0, thus we have a local minima at 1. At 1. What is f double dash minus 11? It will be 6 into minus 11 plus 30, which is minus 66 plus 30, which is minus 36. It's less than 0, which means we have local maxima at minus 11. Thus we have both local minima and local maxima. So fx has a local minima as well as a local maxima. So answer is option B and D. This question belongs to algorithm subject and was asked in GATE CSE 2023. So the question states, let f and g be functions of natural numbers given by f of n equals to n. So we have f of n equals to n and g of n is equals to n square. Which of the following statements is are true? Fn is big O of Gn, Fn is omega of Gn, Fn is small o of Gn, and Fn is theta of Gn. Okay, so when can we say Fn is big O of Gn? So we can say Fn is big O of Gn. Say Fn is big O of Gn if and only if Fn is less than equal to some constant into Gn for all n greater than equal to n naught, for some threshold greater than equal to n naught, and for c is greater than 0 and n naught is the number of inputs, so it should be greater than equal to 1. So let us see whether this condition is satisfied. Can we say n is less than equal to n square? Yes, we can say n is less than equal to n square for all the values greater than equal to 1. I think for all the values we can say this, even if some are lesser values. Let us suppose 1 by 2 and 1 by 4. No, we can't say for this. So for all n naught greater than equal to 1. So for all n greater than equal to 1, we can say that this condition holds true, as 1 is less than equal to 1 square, 2 is less than equal to 2 square. Thus, Fn is big O of Gn is true. And when can we say that Fn is small o of Gn? So we can say that Fn is small o of Gn if and only if this equality shouldn't be there, which means Fn shouldn't be equal to Gn but should always be less than Gn. Can we say that Fn will always be less than Gn above a particular point? Yes. For all n greater than 1, which means starting from 2, we can say that Fn will always be less than Gn. Thus, small o is also true. Okay, now let us see when can we say that Fn is omega of Gn. So we can say Fn is omega of Gn if Fn is greater than equal to c into Gn for all n greater than equal to n naught, c greater than 0 and n naught greater than equal to 1. Can we say that for a particular value Fn will always be greater than Gn? No, we can't say. As the graph for Fn will be something like, for a value 1 it will have a value 1, for value 2 it will have a 2, so it will be like this, and the graph for Gn will be something like this. This is f and this is g. So we can't say that f will be greater than g. F can't be greater than g. Okay, for smaller values it might be possible, as if we have 1 by 2, then 1 by 2 is less than equal to, is greater than 1 by 2 square, which is 1 by 4. But for it should be true for all the values. So this is false. Omega is false. Okay, theta. So when is theta valid? Theta is valid when Fn is both big O of Gn and omega of Gn. Then we can say that Fn is theta of Gn. But here it is big O of Gn but not omega of Gn. So not theta of Gn. So answer is option A and option C is true. It was an MSQ type question. So answer is option A and C. This question belongs to engineering mathematics subject and was asked in GATE CSE 2023. So the question states, let A be the adjacency matrix of graph with vertices 1, 2, 3, 4 and 5. Let lambda 1, lambda 2, lambda 3, lambda 4 and lambda 5 be the 5 eigenvalues of A. Note that these eigenvalues need not be distinct. The value of lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 plus lambda 5 is. Okay, so first of all, let us draw the adjacency matrix. There is a shortcut to this too, I will tell you in the end. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1 is adjacent to 2 and nothing else. 2 is adjacent to 3 and 4. 2 is adjacent to 3 and 4. 3 is adjacent to 3, 2 and 5. 3 is adjacent to 2, 3 is adjacent to 5, 3 is adjacent to 3. 4 is adjacent to 4, 4 is adjacent to 2, 4 is adjacent to 5 and nothing else. 5 is adjacent to 3 and 4 and nothing else. So what is the sum of eigenvalues? For a matrix, the sum of eigenvalues is equals to the trace of matrix. And what is the trace? Trace is the sum of diagonal elements. So what are the diagonal elements sum? 0 plus 0 plus 1 plus 1 plus 0. So answer is 0 plus 0 plus 1 plus 1 plus 0. So lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 plus lambda 5 is 2. There is a shortcut to this. See, sum of diagonal elements is equal to trace of matrix. Trace is equal to sum of diagonal elements. Now a diagonal element will be 1 only when we have a self loop. Only in case of a self loop, we will have a diagonal element as 1. So we can write this equals to number of self loops. This is the shortcut. So number of self loops is equals to the sum of diagonal elements. So there are two self loops. So sum of diagonal element is 2. This question belongs to engineering mathematics subject and was asked in GATE CSE 23. So the question states the value of the definite integral. So it's a triple integration question is rounded off to the nearest integer. Okay, so let us see what this question states. It's minus 3 to 3, minus 2 to 2, minus 1 to y. 4x square y minus z cube dz dy dx. Okay, so this is the z limit, this is the y limit, and this is the x limit. As the innermost limit is for dz, then for dy, then for dx. Okay. First of all, let me tell you a property. If we have an odd function means f of minus x is equals to minus of fx. Then its integration from minus a to a of fx dx will be 0. Okay, so first let's integrate it in terms of minus 3 to 3, minus 2 to 2 in terms of z. So this will become 4x square yz with a limit from minus 1 to 1. Okay, and this is an odd function, as if we have z cube, then f of minus z cube is equals to minus z cube, which is equals to minus fx, f of minus fz. So this is an odd function, so its integration will be 0. Okay, now we have dy dx, so it is equals to minus 3 to 3, minus 2 to 2. It will become 4x square y minus of, into z is 1, minus of 4x square y and z is minus 1. So it will become 8x square y dy dx. Now see, this 8x square y is again an odd function, as if you do f of minus 8x square y, then it is equals to minus f of 8x square y. So it is an odd function. So its integration in terms of y will be 0. And then we will be having 0 dx minus 3 to 3. So its integration is 0. So answer is 0. So this question is basically based on odd functions. So if we have limit minus a to a of an odd function, then its integration will be 0. So answer is 0. This question belongs to digital logic subject and was asked in GATE CSE 2023. So the question states a particular number is written as 132 in radix 4, which means base 4 representation. The same number is written as what in base 5 representation. Okay, so if we want to convert from a non-standard base to another non-standard base, we will use base 10 as an intermediate form. So we will convert base 4 to base 10. So how do we convert it? We have 132 base 4. So it can be written as, if we have any number like ABC base B1, then it is equal to A into B1 square plus B into B1 plus C into B1 power 0. The powers of B1 increase and its equivalent in base 10. So its equivalent in base 10 will be 1 into 4 square plus 3 into 4 to the power 1 plus 2 into 4 to the power 0. So it's equal to 16 plus 12 plus 2. So it's equal to 30 in base 10. And for converting any number to from base 10 to any other base, we just divide that 30 number with that base. So 5 6 are 30, remainder is 0. 5 1 is 5, remainder is 1, and we have 1 over here. So its value is read from bottom to top. So answer is 110 base 5. You can also cross verify it by converting it to base 10. It will be 1 into 5 square plus 1 into 5 to the power 1 plus 0 into 5 to the power 0. It will become 0, it's 25 and it's 5. So we can verify it is getting 30. So answer is 110 in base 5. This question belongs to computer organization subject and was asked in GATE CSE 2023. So the question states, consider a three-stage pipeline processor. So we have three-stage pipeline. Okay, let us assume stage 1, stage 2 and stage 3 with a delay of 10 nanosecond, 20 nanosecond and 14 nanosecond for the first, second and the third stage respectively. Assume that there are no other delay and the processor does not suffer from any hazards. Also assume that one instruction is fetched every cycle. The total execution time for executing 100 instructions. So we have n equals to 100 instructions. And how many stages? Let k denote the number of stages in a pipeline. Then we have 3 stages. Okay. Let us calculate what is the TP. So what is TP? It is pipeline delay. So what is the value of TP? TP value has the value max of all the delays of each pipeline. S1, S2, S3. So it has value max of 10, 20 and 40. So it's 20 nanoseconds TP. Now we have a direct formula for calculating the total execution time. Let us denote it by capital T. So capital T equals to K plus n minus 1 into TP. You can use this formula directly. So we'll have 3 plus 100 instructions. So 100 minus 1 into 20 nanoseconds. So we have 101 into 20, which is 20, 100 plus 3, 103 minus 1, 102 into 20, 2040 nanoseconds. So answer is 2040 nanoseconds. This question belongs to computer organization subject and was asked in GATE CSE 2023. So the question states, a keyboard connected to a computer. So we have a computer and a keyboard connected to the computer is used at a rate of 1 keystroke per second. So in 1 second, we are having 1 keystroke. Okay. The computer system pulls the keyboard every 10 milliseconds. So computer is asking the keyboard every 10 millisecond and keyboard stroke is there 1 per second. Okay. To check for a keystroke and consumes 100 microseconds for each pole. And for each pole, 100 microsecond is consumed. Okay. If it is determined that after polling that a key is pressed, the system consumes an additional of 200 microseconds. 200 microseconds is the processing time and this is the polling time. Okay. Let T1 denote the fraction of time spent in polling and processing a keystroke. Okay. So let us take a default time of 1 second. So what happens in the entire 1 second? So as we are having one poll in 10 millisecond, which means one poll in 10 to power 10 into 10 to power minus 3 second, which means one poll in 10 to power minus 2 seconds. So in 1 second, how many poles will be there? There will be 1 by 10 to power minus 2 poles, which is equals to 100 poles. So what will be the total polling time? One polling time, we have 100 poles and each pole has a 100 microsecond polling time. So we will have 10 to the power minus 2 seconds, or we can write 10 milliseconds is the total polling time. Okay, and what will be the processing time? Processing time in the entire this 1 second, only one processing time will be there, as only one keystroke will be there. So it will be equal to 200 microsecond, or we can say 200 into 10 to the power minus 6 seconds, or we can say 0.2 milliseconds. So what is the total time? Total time is 10 plus 0.2. So we can say T1 equals to polling time, poll time plus processing time, which is equals to 10 plus zero point 0.2, which is equals to 10.2 millisecond. Okay. Now let us consider the second scenario. So in second scenario, what happens is, in an alternative implementation, the system uses interrupts instead of polling. So we are using interrupts. An interrupt is raised for every keystroke. So we do not have a polling time. Polling time is not there. We have processing time, but for each second an interrupt will be raised by the keyboard to the CPU. And for each interrupt, we have interrupt service routine. It takes a total of 1 millisecond for servicing the interrupt. So for processing this interrupt, we have 1 millisecond. And processing a keystroke. So both keystroke and the interrupt takes only 1 millisecond. Let T2 denote the fraction of time spent in servicing the interrupt and processing the keystroke. So what is T2 time? It's 1 millisecond. So it is asking us T1 by T2. So what was T1? It was 10.2 millisecond. And what is T2? It's 1 millisecond. So what is the fraction? Fraction is 10.2. Or we can also call this as speed up. So speed up is 10.2. What is the mean of speed up? Speed up means if instead of the first approach we are using the second approach, then it will be 10.2x times faster than the first approach. So answer is 10.2. This question belongs to programming subject and was asked in GATE CSE 2023. So the question states, the integer value printed by the ANSI C program given below is. So we have a program and we need to tell the value printed. So we have a main function and a funcp function. So every time main is called first. So main has two local variables, a variable x and a variable y. X has address 1000, y has address 2000. Okay, it has garbage value initially, as these are local variables. And during the compile time, due to the static int, a static variable x is created with the address 3000 and a default value 0. Okay, now at the runtime, these two variables x and y are created with garbage value. Then funcp function is called. So we come over here, do static int x equals to 1. So this value is changed to 1. X plus plus, so it is changed to 2. Return x. So 2 is returned to funcp. 2 comes over here and is stored in variable x. So 2 is stored over here. Then we do y equals to funcp plus x. So funcp is called again. Initialization is not done, it's done only once. Then we have x plus plus, so it becomes 3. It returns x means it returns 3, so we get 3 over here. 3 plus x. So what is this x? Local x will be used. What is local x? Local x is 2. 3 plus 2, 5. Y has value 5. Then we are printing just x plus 5. So what is 2 plus 5? It's 7. So the answer to this question is 7. This question belongs to programming subject and was asked in GATE CSE 2023. So the question states, consider the following program. So we have a main function, f1 function, f2 function and f3 function. Which one of the following options represents the activation tree corresponding to the main function? So we know always main function is called first in the activation tree. Okay. Now main calls three functions, f1, f2 and f3. f1 will come, then f2 will come, then f3 will come. Okay, so initially f1 will be called. When f1 is called, then we have a return statement. So f1 returns, it stops over here. Okay, then we will come to f2. f2 is called with the value 2. Okay, so it will call f3. Then as it is called with the value 2, it will check x is equals to 1. No, it is 2. So it will do the else part. So see, let us do it in the leftmost order only. So initially main is called, main will call f1, f2, f3. f1 will return, then f2 will be called. f2 will call f3. Okay. Then what f3 will do? f3 will then again go inside it. f3 will return. Okay. Then we will come over here. Here the value was 2. So we will go to else part. This will call f2 with a value 1. So now as it is x minus 1, so x was 2, so 2 minus 1, 1. So now it is 1. Now it will call f3. F3 will go and return, and then it will come in the if part because x is 1. So it will call f1. F1 will just return. Then we will come to f3 part. F3 will just return. So answer is main f1, f2, f3. F2 calls f2, f3 as here the value was 2 and here value was 1. So the answer is option A. So option A is the correct answer. Main calls f1, f2, f3. F2 calls f3, f2 and f2 calls f3, f1.
This is a question from liveness analysis. We are given a control flow graph and we are asked to find out which following choices correctly list the set of live variables at the exit point of each basic block. So first of all, let's understand what is liveness analysis in compiler design. So liveness analysis consists of a specified technique that is implemented to optimize register space allocation for a given piece of code, and it facilitates the procedure for dead code elimination. So liveness analysis has two major uses. One is dead code or elimination. Dead code elimination. And the other is register allocation optimization. So these are the two important uses of liveness analysis. Now, a liveness analysis is a classic data flow analysis used to calculate the variables that are live at each point in the program. A variable is live at some point if it holds a value that may be needed in the future, or equivalently if its value may be read before the next time the variable is written to. So in the question we are asked to find out what are the live variables at the end of each exit point of the block. Now in order to calculate the live variables, we have to understand some of the basic definitions that are involved. So first is in of a block. This is the set of variables that are live before entering the block B. Now we have out of B. These are set of variables that are live just after exiting block B. Then we have the terminology use. It represents variables that are used in block B before any assignment. Then we have def or definition, that is variables that are assigned in block B. Now how to find use and def? We can find use by looking the RHS of the variables, and they should not be present in LHS. That is a simple statement. That is use. Then for def, the variable is present in the RHS. We are considering that as def. Now we have a basic formula to calculate in and out. And using this, we have an algorithm which calculates what are the live variables that are present at the exit point of a basic block. Now, the basic formula to calculate in and out is in for a particular block B is equal to use of B, that is variables that are used in block B, union out of B minus definition of B. This is what in of B means. Now, out of B, it means that union of in of all successors of n, that is S belongs to successors of B. This is the two basic formula. Now using this we can try to find out what are the live variables. So let's begin. So let's solve. Initially let's write down the blocks. This is B1, block B2, block B3 and block B4, and let's write the use and def first. Now we'll go iteration by iteration, and using these two formulas we'll try to find the live variables. So use and def. So for block B1, use means M and N are use because they are part of the RHS. So M and N. For B2, we have I and J. For B3, we are having 5 because this is just a number. For B4, we have A. This is initially the use. Now let's find the def. That is definition. For in block B1, we have I, J and A. I, J and A in definition. For B2, we have I, J as they are defined here. For B3, we have A. For B4, we have I. Now, let's try to find out the in and out of all the blocks. So, in the first go, we have in and out. This is first go. Now, let's try to calculate in. So, in is basically use of B union out of B minus def of B. So, use of B is what? M comma N. This union out of B we do not know now, so let's leave it as it is, minus def of B. So without finding out of B we cannot find it, so in first go let's leave it like this. For B2, in similarly we are writing I comma J since we do not know out of B. For B3 it is 5 and for B4 it is A. Essentially we are writing use once again here. Now in out is actually union of all the successors of in of S. So what happens here is that for block B1, B2 is the successor because there is a node from B1 to B2. And the in of B1 is what? It is use of B1 union out of B1 minus def of B1. So right now we are only having use. So we'll write it as it is. M comma N. Now for B2, the successors are B3 and B4. So for B2, we have two successors, B3 and B4. So in of B3 is what? In of B3 is 5 and in of B4 is A. So their union will be A. Now we have B3. B3 has a successor that is B4. So in of B4 is what? In of B4 is right now A. So we are writing A. Now B4 has successor B2. Now we are writing in of B2. In of B2 is I comma J. This is the first go. Right now we are only having this use part to find out the in as well as the out. Now in second go we have in and out. Let's try to find out the in and out based on second go. So in second go the in of block B1 is use of B union out of B minus def of B. So this in we can directly write. This is the use part, that union out of B minus def of B that we are trying to find. So this is m comma n, that union out of B. Out of B is m comma n. So m comma n minus def of B1, that is I, j and a. So there is no difference here. That is m comma n minus I, j, a will result in 5. So this is as it is, m comma n. Now for B2, this is I comma j, I comma j union out of B. Out of B is a minus def of B, that is a minus ij. So since there is no common, we are writing a. Now for B3, this is use of B is 5 union out of B, that is a minus def of B. This will be 5 only because a minus a also results in 5. So we are getting 5. Now for B4, it is use of B, that is a union out of B is this ij minus def of B, I. So we are getting j. Now what is the out? Out is union of in of all the successors of the blocks. So for B1, the successor is B2. So union of in of B2, that is union of in of B2 is aij, aij. Then we have for B2, we have two successors, B3 and B4. B3 and B4 is defined here. So it will be a comma j. Then for B3, the successor is B4. In of B4 is not given. So in of B4 is actually aj. So we write aj. Then B4 has successor B2. That is in of B2. We write aij. aij. Now let's write the third round here. We are continuing this until the current and the previous in and out are similar. So in the third round, we will get this. In third round, we have in and out, and the blocks are B1, B2, B3 and B4. So for in, what happens is use union out of B minus def of B. So for right now we have in as m comma n, that is present in use, m comma n minus out of B, that is aij minus def of B minus aij. So this is 5, we will get m comma n. Next we will have use of B. Use of B2 is ij comma out of B minus def of B. Out of B is aj, def of B is ij. So we are getting a here. So we have aij. Now in the third round for B3, what is in? Use of B3 is 5, but we have out of B minus def of B. Out of B is aj and def of B is a. So we are getting j here. And for B4, use is a. Then we have out of B aij minus I. We will get a and j. So a union aj is a comma j. Then out. Out is union of in of all the successors. So for B1, we have in of B2 that we have to find out. In of B2. In of B2 is iaj. We will get aij. The order doesn't matter. Now for B2, we have B3 and B4. B3 and B4 has aj as its successors union, a comma j. Now B3 has B4 as the successor. So we have aj here. And B4 has B2 as the successor. In of B2 is aij. aij. Now in the fourth iteration, what happens? We have in and out. This is the fourth iteration. So for B1, the in is what? So for B1, the in is use of B, that is mn union out of B minus def of B. So we have m comma n, then union out of B. Out of B is aij minus def of B, aij. So this is m comma n. So for B2, use is ij, and we have def of B, that is out of B, that is aj minus ij. We have a as common. Similarly, we will have j here as well as aj here. So similarly for out, when we do it, we will get aij, aj, aj, and aj, aij, aij. So the algorithm stops because the current one and the previous blocks of in and out are similar. So this is the stopping criteria. Now let's try to find out what are the blocks that are live during each cases. So for block B1, the out, since we are trying to find out at the exit point, so the out is aij. For B2, we have aj. For B3, we have aj, and for B4, we have aij. So let's see the different options. So based on the options, option D, B1 has aij, B2 has aj, B3 has aj, and B4 has aij. It is matching. So option D is the correct answer here.
This question belongs to operating system subject and was asked in GATE CSE 2023. So the question states, consider the two functions INCR and DSCR shown below. So we have INCR function which does weight on a semaphore variable S, does x equals to x plus 1, then does signal on S. We have DCR variable that does weight on S, x equals to x minus 1 and signal of S. There are 5 threads, so we have basically 5 threads, out of which 3 does INCR operation once, out 5 threads each invoking INCR once, and 3 threads. So totally we have 8 threads in which 5 does INCR once and 3 does decrement operation once on the same shared variable x. So x is a shared variable among both these functions, all the threads. The initial value of x is 10. Okay. Suppose the two implementation of the semaphore S is as follows. So either S can be a binary semaphore or a counting semaphore. In implementation 1, it is a binary semaphore with initial value 1, and in implementation 2, it is a counting semaphore with initial value 2. Let V1 and V2 be the values of X at the end of execution of all the threads with implementation I1 and I2. So here we will get a V1 value and a V2 value after execution of all these 8 threads. Which one of the following choices corresponds to the minimum possible value respectively? So we have to find the min V1 and minimum possible value of V2. Okay. So let us see how we can do this. Okay. See, first case is when we have a binary semaphore. Binary semaphore. So what is the value of semaphore? It's 1. It's a binary semaphore and we have weight or signal, which means there will be mutual exclusion. Mutual exclusion is guaranteed, which means at a time only one process can be in critical section. So if we have x initially as 10, then 5 operations of this increment will be done by the 5 threads. It will increment it to plus 5 and then 3 decrement will be done. It will be done minus 3. So x will have a value 10 plus 5, 15 minus 3, 12. In every case, whatever be the case, if we have increment, decrement, increment, decrement, increment, decrement, then 2 increments, whatever be the permutation of all these 8 operations, we will always get a 12. So minimum of V1 is 12. Now let us see the second case. In second case, we have counting semaphore. We have a counting semaphore S. Counting semaphore S. So what is the value of S? S is 2 and the value of X is 12. Okay. So as we have counting semaphore 2, which means at a time 2 threads can execute their critical section. As one of the thread will make this 2 as 1 and will enter the critical section, and then another thread can also enter critical section by making this 1 as 0. Okay, so 2 threads can be in critical section at a point of time. Thus, mutual exclusion is not guaranteed. So we may be able to get some other minimum value. Okay, so let us break down this complex statement. So increment can be break down into 3 parts: load x, increment x, and store x. See, or even I can write it more clearly, like load x in register R1, increment the value of register R1, increment R1, store R1 in X. And similarly, I can break down it as load X in R2, increment R2, and then store R2 in X. Okay, now let us see the operations. We have initial value as 10, not 12. Okay, we have X as 10. So what happens now? So initially X is 10 and S is 2. So suppose one of a thread comes to this increment operation. Okay, so semaphore value is reduced by 1 due to this wait. Then it loads the value of X, which is 10 in register R1. So what R1 has? R1 has 10. Okay. Now suppose this process gets preempted. This thread gets preempted over here. So preemption is done over here. Now another thread comes and decrements R2. So it does wait. So S is reduced to 0. Now it load X in R2. So R2 has a value 10. Now can any other thread come? No, as semaphore value is 0. So either thread 1 will execute increment or thread 2 will execute decrement. Suppose thread 1 executes the increment. So it increments R1 to 11 and store R1 in X. So what is the value of X? X is 11. Now suppose one increment is done, 4 increments are remaining. Let us suppose we do all the 4 increments. So 11 is incremented by 4, so the value is 11 plus 4, 15. Okay, so all the increments are done. Now we come in this decrement. So here we will decrement R2. So 10 is decremented to 9. Here we do not use this global X. We use the value stored in the register R2. So 10 is decremented to 9 and store R2 in X. So X is updated to R2, which is 9. One decrement is done, 2 decrements are left, then we perform 2 decrements. 9 minus 2, the value is 7. So final value is 7. Why it happened? Because mutual exclusion was not guaranteed. Thus we can have two threads in critical section. So V2 is 7 and V1 was 12. So answer is 12 and 7, option C. This question belongs to theory of computational subject and was asked in GATE CSE 2023. So the question states, consider the context-free grammar G given below. S implies ASB or X, X implies AX, XB, A or B, where S and X are non-terminals and A and B are terminal symbols. The starting non-terminal is S. Which one of the following statements is correct? So it is asking the language generated by G is. So let us see what happens with E is the production rule. We know we have S implies ASB. Then again we can, in place of S we can put ASB. So in place of S we can put ASB B. Then again in place of S we can put ASB. So we'll get triple A S triple B. Which means using this we can have any number of equal number of A's and an S followed by equal number of B's. Okay, but see now we need to terminate it with the X, so we will have A to the power M X B to the power M. Okay, but now see what is X. X can be replaced by AX or XB. So if we replace X by AX, we have A to the power M x by ax b to the power m. Again, if we replace it by ax x by ax b to the power m. So initially it was equal, but later on we can remove this equality. So the equality is not at all followed. Okay, so we have any number of a's followed by any number of b's, and we can also here alternatively we can replace a to the power m x by xb also b to the power m. We can replace anytime we can replace x by here we can replace x by xb b to the power m. Again, we can replace x by ax also, ax double b to the power m. So we can have any number of a's followed by any number of b's, and x will be in middle. And what will x be replaced by? X will be replaced either by a or by b, and b to the power j, which means it is just a followed by a b. Okay. Now we need to check what is the condition, whether null is accepted or not. See, if we write s as a as b, then null is not accepted here. We need to write s as x and x as either a or b, which means null is not accepted. The minimum string accepted is either a or b. Okay, which means x can be replaced only by a and b, which means either m is greater than equal to 1 or n is greater than equal to 1. And if we write the regular expression, then it will be any number of a's followed by any number of b's, and x can be replaced either by a or b. So this a plus b makes sure that null is not accepted. Either a or b is the minimum string being accepted. So answer is option B. The language generated by G is a star, a plus b, b star. And as we can write the regular expression, thus it is a regular language. So option D is also correct. Incorrect. The language generated by G is not a regular language. It's false. It's a regular. This is false and this is false. As here null is accepted, and here we can have a, b and a, but a, b and a is not at all accepted. Like here we can have something like a, b, and then we can have an a. But we can't have, we need to have all the a's followed by all the b's. We can't have a, b, a, something like that. So answer is option B. This question belongs to theory of computational subject and was asked in GATE CSE 2023. So the question states, consider the pushdown automata PDA P below. So this is a PDA P, which runs on the input alphabet A comma B. So A comma B is the input alphabet which can be present on in our string. So string can have either A or B. Has stack alphabet perpendicular or A. So we have a stack, and stack can have either a stack which can have either only perpendicular or A. And three states S, P and Q. So we have state S, state P and state Q. With S being the start state, S is the start state for the PDA. A transition from state U to state V labeled C, X, gamma. So what is the meaning of C, X, gamma? So here C will be the input symbol which will be present in our string. Either C is the input symbol or it can be an epsilon. Okay. X is the start symbol, which means it is the top of stack, the item present on the top of stack. And gamma is the string of stack symbols. And gamma is the string of stack symbols, which means it will tell what operation we will perform when we see on top of stack this and input item as C. Represents the fact that in state U, the PDA can read C from the input with X on top of its stack, pop X from the stack, and push in the string Y on the stack. Okay. And go to state V. So it is telling that we need to transition from U to V on seeing this symbol. In the initial configuration, the stack has only the symbol perpendicular on it. So initially, we just have perpendicular in our stack. Okay. PDA accepts the empty stack. Okay. So let us see what is happening over here. So it is given that PDA accepts the empty stack. So if PDA can accept the empty stack, then what will happen? If we have an empty stack and we are over here, then it means PDA will accept it. So which means, and now let us see what will happen. Suppose we have a string like A. So what happens when we get A and top of stack is perpendicular? If we get A and top of stack is perpendicular, then we basically push A on the stack. Okay. And if we get another A, then what happens? If we get another A, then we push an A for each A. So an A is for each A and capital A is pushed on the stack. Okay. Now suppose the string ends over here and we get epsilon. Then what happens? If we get some epsilon over here and top is A, then we pop the A. Okay. And for each A we pop the item from the stack. Okay. And when we get a perpendicular, then we accept it. Perpendicular we accept it, which means triple A is accepted. Okay. Is empty stack accepted? Yes, empty stack is accepted. It is given in the question. The PDA accepts the empty stack. Okay, which means when the stack becomes empty, the PDA directly accepts it. Okay. Now let us see. If we have only, which means triple A is accepted. Now let us see another case. Suppose we just have the stack symbol perpendicular over here, and we got nothing in the string, just the epsilon. Then what will happen? There is no production on epsilon, so epsilon is not accepted. Okay, so we can make some note that if A has a power m, then definitely m should be greater than equal to 1. As if we have a single A, then A on perpendicular will be replaced by A, and then A on seeing epsilon, we will reach to this Q state and we'll pop this, and seeing perpendicular we will pop this and we will accept with an empty stack. Okay, so m should be greater than equal to 1. Now let us see what is the condition for B. See, is only B accepted? Let's see. Suppose this is our stack over here with perpendicular in this, and we get just B. So if we have a B, but there is no symbol, no operation with the top perpendicular. There is an operation with top A but not with top perpendicular. So this is false, which means at least a single A should be there. Okay. Can we have A followed by a B, which means equal number of A's and B's. So A with a perpendicular will push A. Okay. And then if we get B with the top as A, then we will remove this. Okay. And then if we get a B but top should be A. Okay, which means if we have B to the power n, then m should be basically greater than n, or n should be less than m. Equals are not accepted. If we have more A's, then let's see what happens. If we have more A's and a perpendicular over here, then on seeing A and top delta, A will be replaced by A. On seeing A, top A will be replaced by A. And seeing B, a top A, it will be popped. On seeing gamma, seeing null, top A, it will be popped. On seeing null, top delta, it will be popped, and empty stack is accepted. So answer is A to the power m, B to the power n. M should be greater than equal to 1 as null is not accepted, and n is less than m, which means number of B's should be less than number of A's. So answer is option A. A to the power m, B to the power n. M should be greater than equal to 1 and n is less than m. This question belongs to compiler design subject and was asked in GATE CSE 2023. So the question states, consider the given C code and its corresponding assembly code. So here we have this C code over here, which is int two arrays A and B of size 10 and an integer I. Integer is of size 32 bits. So for int I equals to 0, I is less than 10, I is less plus, A of I equals to B of I into 8. So what is it doing? We have A and B with 10 slots, 0 till 9, 0 till 9, and it is multiplying it by B by 8 and storing it in the corresponding address of A. So this is performing this step. Okay, and here we have the corresponding assembly code. Some useful with few operands U1 to U4 being unknown. So U1, U3, U2, and U4. These are unknown values. Some useful information as well as semantics of each unique assembly instruction is annotated as inline comments in the code. The memory is byte addressable. So we have a byte addressable memory. Which one of the following options is correct replacement for operands in the position U1, U2, U3, U4 in the above assembly code? So we basically need to find the corresponding value for U1, U2, U3, and U4. Okay, let us see. So here this is the assembly code where comma indicate comments. Okay, so all these are comments. R1 to R5 are 32-bit register integers. Okay, which means they can directly store the integer I. Okay, initialize r1 to 0 and r2 to 10. Okay, so what is r1? R1 is 0, r2 is 10. So as you can see, 0 is used for this and 10 is used for this. Okay, initialize r3 and r4 with the address of a and b. R3 has address of a and R4 has address of B. Okay. Now let us see. L01 JQ R1 R2 end, which means if R1 equals to R2, go to end. R1 equals to R2, which means 0 and 10 becomes equal, which means this statement becomes false. Then we need to exit this loop. Yes, then we need to go to end. Okay, so this line is fine. This is the terminating condition. Now here what we have done? We have done R1, we have stored in R5 the memory location of R4 plus 0. Okay, so what is R4? R4 has our B. So memory location, R4 has address of B. So memory location of R4 has the value B. So we stored R5. So R5 will contain our value B. So R5 has value B. Okay. Yes. So R5 has the memory location at R4 plus 0. Sorry. R4 has the memory location of B. Then R5 has the memory location of B. It has address of B. So R5 just has B. Now what we have done? Let me tell you what is happening over here. See. Here we have R3. So let us suppose we have a value of A over here with address 1000. So R3 has 1000. Suppose we have a value B over here with the address 2000. So R4 has 2000. Now what we have done? R5 has the value at memory location R4, which is R5 has the value at memory location 2000, which is B. So R5 has our B over here. Okay, so this is done. Now what we are doing? We are doing shifting R5 by U1 times. Okay. So what we need to do over here? See, here we are multiplying B with 8. So what is the binary for 8? It's 1000. So we need to basically shift it by 3. Suppose it was 8. Suppose it was 10. Okay. Let me take another number so that you do not get confused. Suppose it was 23. Okay, and we are multiplying it by 8. So what is its equivalent? We write the binary for 23 and shift it by 3. It is equivalent to multiplying 23 by 8. So what is 23 into 8? It's 24, it's 16, 184. So instead of writing 184, we will write the binary for 23, which is 2, 3, 4, 8, 16, 17, 18, 19, 20, 21, 22, 23. This is the binary for 23, and we will shift it left by 3, which means we will add 3 zeros. Then it will become equal to 184. So here we are also doing the same thing. We need to shift it by 3 so that it indicates multiplication by 8. Okay, now what we are doing? We are storing the value of R5. So what R5 has? R5 now has B into 8. R5 now has B is into it due to left shift by 3. Now we are storing this value where we need to store in R3. What R3 has? R3 has, we go to the address R3 and store this value. So B into 8 is stored in place of A. So A will now have B into 8. So this is what we need to do. A will have B into 8. Okay. Now what we are doing? We are doing R3 equals to R3 plus U2. Okay, so what is R3? R3 has address A, which means address 1000, which is the starting address. Suppose this is the starting address for the array. So next item will be at what address? See, it is byte addressable and integer is 32-bit. So what is 32-bit? 32-bit is 32 by 8, which is 4 bytes. So basically we need to shift it by 4 byte to go to the next address of 1000. 1 2 3, it will start from 1004. So basically we need to add 4 to go to the next address. Okay, and here also we need to add 4 to go to the next address in case of B, as R4 has B. So here we are incrementing to the next position, which means we are changing the value of I from 0 to 1 so that we can access the second item in both A as well as B. Okay, so U2 is 4 and U3 is 4. Okay, so we will keep performing this. Now what is it is doing? it is adding R1 to 1 so that we can keep track of the terminating condition. We need to go till only 10. Now what it is doing? It is going go to U4. So where we need to go after this? We need to go to the starting condition and check this condition whether I is less than 10 or not. So where we are checking this? We are checking this in this first line L01. So we will have go to L01. So what are the answers? Here U1 has a value 3, U2 has a value 4, U3 has a value 4, and U4 has a value L01. So the answer is 344L01, option B. This question belongs to computer organization subject and was asked in GATE CSE 2023. So let's see what the question states. So the question states a 4 kilobyte memory, 4 kilobyte byte addressable memory is recognized using 4 1 kilobyte memory blocks. So this entire thing is of 4 kilobyte and it is recognized using these 4 1 KB memory blocks. Two input address lines IA3 and IA4 are connected to the chip select port of these memory blocks through a decoder as shown in the figure. So we have IA3 and IA4 connected to a 2x4 decoder and these 4 output are selected to these chip select logic of these 4 memory blocks. The remaining 10 input address lines from IA0 to IA11 are connected to the address port of these blocks. So 2 are over here and remaining 10, which is IA0, 1, 2, 5, 6, 7, 8, 9, 10 and 11 are connected to the address lines of all these 4 chips. So these are 10 bits as 2 has been used over here. The chip select is active high, which means this memory is selected whenever this chip select is active high. Whenever we have 1 over here, then it will be selected. Okay. The input memory addresses IA0 to IA11 in decimal. For the starting locations, address equal to 0 of each block indicated as x1, x2, x3 and x4 in the figure are among the options given below. Which of the following options is correct? Okay. So the thing that this question is asking is that suppose what will be the for each of the starting address, which means for each of the first address of the memory block, what will be the value for IA0 to IA11 in decimal. Okay, so let us first see the table. So here we have IA4 for the decoder table. We have IA4 and IA3 and which chip is selected. Let us see. It can be 00, 01, 10 or 11. Okay. And which chip is selected in case of 00? X1 is selected. In case of 01, X2. In case of 10, X3. And in case of 11, X4 is selected. Okay. And what will be the starting address? So we have IA11 up till IA5. Then we have IA4, IA4 and IA3. Then we have IA2, IA1 and IA0. See, for finding the starting addresses, everything in this address would be 1, which means IA11 to IA5, IA2, IA1 and IA0 will be 0. Okay, for in case of X1 chip. In case of X1 chip, everything will be 0. In case of X2 chip, everything will be 0, 0, 0, 0. Same for X3 chip and X4 chip. Everything will be 0. As we need to get the starting address. So everything will be 0. But IA4 and IA3 we will get from the decoder as these are not part of address, so we can't assume them to be 0. So for X1 it will be 0, 0. For X2 0, 1, X3 1, 0 and X1 1, 1. So let us see the corresponding decimal value. So decimal value for this is 0. For this it is 8. For this it is 2 to 4 to 8, 16. And for this it is 24. So correct answer is 0, 8, 16 and 24. So answer is option C. This question belongs to digital logic subject and was asked in GATE CSE 2023. So the question states, consider a sequential digital circuit consisting of T flip-flops. So we have 2 T flip-flops and D flip-flop. We have 1 D flip-flop as shown in figure. Clock in is the clock input to the circuit. So this is the clock input to the circuit. At the beginning, Q1, Q2 and Q3 have values 0, 1 and 1 respectively. Which one of the following values of Q1, Q2 and Q3 can never be obtained using this digital circuit? 001, 100, 101 and 111. So we need to tell which state is non-reachable. So let me first draw the table. So we have Q1, Q2 and Q3. Then we have, let us write it as T1, D2 and T3. So what is the value of T1? T1 has the value equals to Q3 complement. As this is a Q3, this is a NOT gate, so Q3 complement and same value is given to T1. What is the value of D2? D2 has the value equals to Q1 and the value of D3, not D3, the value of T3 is equals to Q2. Okay. Now let us fill this table. Okay. So what is no clock pulse, and then we are applying the clock pulses. So initially when we haven't applied any clock pulse, then the value of Q1 is 0, Q2 is 1. It has been given in the question 0, 1 and 1, 0, 1 and 1. So what is T1? It's Q3 complement, 1 complement is 0. D2 is Q1, it's 0. T3 is Q2, it's 1. So we have 0, 0, 1. Now see, how T flip-flop behaves for 0 and 1. For 0, it will retain its previous state. Retain previous state. For 1, it toggles. Okay. And how D flip-flop behaves? D for 0, it retains previous state. And D for 1 gives the output as 1. Okay. Now see. Here we have T as 0. So for T on 0, it retains the previous state. So on first clock pulse, it retains this 0. Then on D on 0, retains the previous state. So what was the previous state? It was 0. Okay. And what is D on 1? D on 1 gives an output 1. Okay. So, and this is, what is Q3 complement? Q3 complement is 1. Sorry, I have made one mistake over here. See, T1 has a value 0. So on 0, it retains the previous state as 0. Okay, D has a value 0. On 0, it retains the previous state as 0. Okay, so it retains the previous state 0. Then T has a value 1. On a value 1, it toggles this 1 to 0. Yes, now it's perfect. And what is Q3 complement? Q3 complement is 0, complement is 1. What is Q1? It's 0. What is Q2? It's 0. Okay. Now when second clock pulse is applied, what is T? T has a value 1. So it toggles. It toggles 0 to 1. Okay. What is D? D has a value 0. It retains the previous state of 0. D has a value 0. So it retains the previous state as 0. Now here, what is Q3 complement? It's 1. What is Q1? It's 1. What is Q2? It's 0. Now on third clock pulse, what happens? T on 1, T on 1 toggles. So 0 is toggled to 1. Sorry, 1 is toggled to 0. Then D has a value 1. So on 1, it gives the output as 1. On 0, it retains the previous state as 0. Okay. Now, what is it? Q3 complement is 1. Q1 is 0. And Q2 is 1. What happens in the fourth clock pulse? In the fourth clock pulse, T has a value 1, so it toggles 0 to 1. D has a value 0, so it retains the previous state. D has a value 1, so it gives the output as 1. What is Q3 complement is 0. What is Q1 is 1. Q2 is 0. Now on fifth clock pulse, what happens? T has a value 0, so it retains the previous state as 1. D has a value 1, so it gives output 1. And here T has a value 0, so it retains the previous state. What is the previous state? Is 1. Okay. Now here we will do Q3 complement is 0, Q1 is 1, Q2 is 1. Now 6th clock pulse. So what happens in 6th clock pulse? T has a value 0, so it retains the previous state as 1. Okay. D has a value 1, so it gives the output as 1. T has a value 1. So what happens when T has a value 1? Then it basically toggles. So 1 is toggled to 0. Okay. Now here we have Q3 complement as 1, Q1 as 1 and Q2 as 1. Okay. So what is the 7th clock pulse is applied? T has a value 1, so it toggles 1 to 0. D has a value 1, so it gives output as 1. T has a value 1, so it toggles 0 to 1. So here we reach back to the same state, 0, 1, 1. So see, 100, 100 is present. This one is 100. 101, 101 is present. 111 is present. Only 001 is not present. So answer is 001. This question belongs to Digital Logic Design subject and was asked in GATE CSE 2023. So the question states, a Boolean digital circuit is composed using four 2-input multiplexers. So M1 and M2 are two 4-input multiplexers and one 2-input multiplexer M3 as shown in figure. X0 to X7 are inputs of multiplexer M1 and M2. So we have X0, X1, X2, X3, X4, X5, X6 and X7 are the inputs of multiplexer M1 and M2 and could be connected to either 1 or 0. So they can have Boolean values 1 or 0. The select line of the multiplexer are connected to Boolean variable A, B and C as shown in figure. So A and C are select lines for the first multiplexer and A and C are select lines for the second multiplexer. And here the output of second multiplexer and B is the select line for the third multiplexer. Which one of the following set of values x0, x1, x2 up till x7 will realize the Boolean function? So we have been given this function a complement plus a complement c complement plus a b complement c complement. And for this output we need to tell what should be the input. Okay. So as you know, the output of a multiplexer, how a multiplexer works. Suppose we have two select lines S1 and S0. Then they can have a value 0, 0, 0, 1, 1, 0 or 1, 1. Okay. But here for this multiplexer only one select line is there. Only one select line S is there. So S can have a value 0 or it can have a value 1. And what is the output? If S has a value 0, then the output is the one that comes from over here. Let us write it as B complement. And if S has value 1, then the output is directly the second one. So you can write the output function something like this. See, the output function can be written something like, for the complemented value B complement some value and then B some other value over here. As for a value 0, when this is 0 it will give this as output, and if this is select line is 1 it will give this as an output. So it will be in the form of B complement and B. So we basically need to convert this to that form. Okay, so let us see what we have. We have f equals to a complement plus a complement c complement plus a b complement c complement. So how can we convert it? Let us first try to minimize it by taking a complement as common. So we have 1 plus c complement plus a b complement c complement. What is 1 plus anything is 1 only. So we have a complement plus a b complement c complement. Okay. Now we have to include the b term and c term. So how we will do is this? We will add it, like we will have a complement, b plus b complement as it is 1, c plus c complement we can add as it is 1, and then we will have a b complement c. See, the question has a b complement. Okay, yeah, we have just made a mistake. Here it is a b complement and c, not c complement. So this is a b complement and c. Then we have a b complement and c. Okay. Now what will happen? We will try to expand it. So we will have f equals to a complement bc plus a complement bc complement plus a complement b complement c plus a complement b complement c complement plus b complement ac. So it will expand like this. Now let us see if we can take this b complement as common. So taking b complement as common, we will get a complement c plus a complement c complement plus ac. And taking b as common, according to this equation, we will get A complement C plus A complement C complement as common. Okay, so we have written it in the form B complement into something plus B into something. Okay, now let us see what we can do. Suppose, but for this part, B complement into something. So how the trig table looks like? We have S for 0 and 1, F. If S is 0, which means B complement, then we go to this output of multiplexer M1. Let us write it as F1. This F1 and this is F2. And when it is 1B, we will get this lower one, the output of multiplexer M2, which is F2. Which means this A complement C plus A complement C complement plus AC will map to over here. So this will be mapped to A complement C plus A complement C complement plus AC, and this will be mapped to A complement C plus A complement C complement. Okay, so half of our work is done. Now let me clear these things out. Okay, so now what we need to do, we need to find what should the input to get this as output. Okay, so let me draw this multiplexer table. So we have S0 and S1. It can have values 0 0, 0 1, 1 0 and 1 1. Okay, see, now what is the output? F1. When both are zeros, output is X0. Okay, so what is A? Let us see, what is A complement C? So A complement C, we get A complement C as output when we have S1 complement S0. S1 complement S0. And what is S1 complement S0? Which means we will have 0 over here and 1 over here. So for 0 1 we will get x1, right? Let me write it to be s1 s0. Now it will be more clearer to you. S1 s0, it can have value 0 0 0 1 1 0 or 1 1. For 0 0 we will have x0, for 0 1 we will have x1, for 1 0 we will have x2, and for 1 1 we will have x3. Now let me show it to you. And what is this? This is mapped to A complement C complement. This is mapped to A complement C. This is mapped to AC complement. This is mapped to AC. Okay. So what is A complement C? So A complement C is present for x1, which means x1 should be 1. A complement C complement is present for x0, which means x0 should be 1. And AC is present for x3, which means x3 should be 1. So all these three should be 1. So x0 should be 1, x1 should be 1, and x3 should be 1, and x2 can have a value 0. As if x2 will have value 1, then this will come in the output. We will have AC complement, but AC complement is not present in output. Let us draw the same table for F2. So we have S1, S0, value 0, 0, 0, 1, 1, 0, and 1, 1. We can write it as, what are our inputs? A and C same. Okay, so from the same table we can see for F2 also from the same table. No need to rewrite the table. So we have A complement C. So A complement C is mapped to x1. So what is x1 for this? For F2, we will have over here x4, x5, x6, and x7. So we have A complement C. A complement C is mapped to x5. So x5 should be 1, x5, and A complement C complement is mapped to x4, which means x4 should be 1. So what are all the 1 values? So what is x1? x1 should be 1. What is x2? x2 has nothing, so x2 should be 0. x3 should be 1. x4 should be 1. x5 should be 1. x6 has no mention, so it should be 0. x7 should be 0. So the answer is, and what should be x0? x0 should be 1. So x0, x1, x2, x3, x4, x5, x6, x7. So answer is 110, then 111, 110, 111, 00. So answer is option C, 110, 111, 00. This question belongs to computer organization subject and was asked in GATE CSE 2023. So the question states, consider the IEEE 754 single precision floating point numbers P equals to 0x C18 00000 and Q equals to 0x 3F5 C2 EF4. Which one of the following corresponds to the product of these numbers? I P into Q, represented in the IEEE 754 single precision format. Okay. So what is IEEE 754 format? So it has three things: sign, biased exponent, and mantissa. It total has 32 bits, in which sign is 1 bit, biased exponent is 8 bit, and mantissa is 23 bit. And as nothing is mentioned, like extended bias, so we will assume normal bias, and its value is plus 127. This is by default if nothing has been given in the question. Okay. Now let us see both the options, both the numbers one by one. So what is P? P has been given as C1800000. This 0x means it is a hexadecimal representation. So its base is H. Now let us try to convert it into a format. Like we will convert it into binary format. So C is 1100, 1 is 0001, then 8 is 1000, then we have 0000 followed by more zeros. Okay. So let us try to group it like this. Sign has 1 bit, so sign is this. Then biased exponent is 8, 1, 2, 3, 4, 5, 6, 7, 8. So till double 1. Then this entire thing is mantissa. Okay. So this is sign, this is biased exponent, and this is mantissa. Okay. So as sign has 1, so it means it is negative. Biased exponent is this. What is its value? It's 131. So what is actual exponent? Actual exponent is biased exponent minus bias. What is biased exponent? Biased exponent is the value is 131. You can convert this, you will get 131. Bias is normal bias 127. So we'll get actual exponent as 4. What is the value of mantissa in decimal? Mantissa is 0, as all are zeros. Okay, so what is our number? So number will come out to be P equals to minus 1 point mantissa, which is 0. This is sign 1 point. Here the mantissa will come into 2 to the power actual exponent, which is plus 4. Okay. Now let us do the same thing for the number Q. So what is our number Q? So number Q is 3F5 C2 EF4. This is given in the hexadecimal format. Now let us try to convert it into binary format. So in binary format, 3 is written like 0011, F is written like 1111, C is written like 0101. Then see, this is 30011, this is F, this is 5, okay, 5. Then we have again C 1100. Then we have 20010. Then we have E 1110. Then we have F 1111. Then we have 0100. Let me cross check. 0011 for 3. Then we have 4 ones. Then we have 0101. Then we have 1100 0100. Yes, perfect. Now let us try to do the grouping in this format: S biased exponent and mantissa. So one bit will be sign, then 8 bits which are till here: 1, 2, 3, 4, 5, 6, 7, 8. This will be biased exponent, and rest all will be mantissa. Okay, so this is sign, this is biased exponent, and this is mantissa. So we have positive sign. Okay, so what is actual exponent? Is biased exponent minus bias. What is the value of biased exponent? If you convert this, you will get 126 minus bias is 127. So you get actual exponent as minus 1. And what is our mantissa? Mantissa is this entire number. Okay. Now let us find what is the value Q. So Q value is plus 1 point. The entire mantissa. The entire mantissa, this one, 1 point m into 2 to the power actual exponent, which is minus 1. Okay, now let me scroll it down. Okay, so here, now what we need to do, we need to find the multiplication. So we need to find what is P into Q. So what is the value of P into Q? See, we have Q is you can easily see that P is a negative number, P is a negative number and Q is a positive number. So P into Q, what will be its sign? So its sign will be a negative number. A negative number means 1. Okay. What will be its actual exponent? So actual exponent is equals to, it will be plus 4 minus 1. So plus 4 plus minus 1. So actual exponent will be 3. What will be its mantissa? Mantissa will be this big number. Let us suppose it to be x. So here x will come. So mantissa is x. Okay. Mantissa is basically 1 point x. So mantissa is 1 point x. Okay. Yeah. Now what will happen? So what is our P into Q? P into Q written in SEM format, sign exponent mantissa format will be minus 1 dot x into 2 to the power plus 3. This is our P into Q. Okay. Now if you, so here sign is negative. So let us try to write it in SEM format. So in SEM format, as sign is negative, so 1 will come. What will be biased exponent? Biased exponent will be normal bias plus this power 3. So it will be equal to 130. See, sign will be 1. Biased exponent will be 130. 130 is equals to 100000010. And mantissa will be same. Mantissa will be equals to x. Mantissa equals to x. Okay. So what is sign is this? What is biased exponent? Biased exponent is 1000010. And what is x? Mantissa is x. So what was the value of x? Let us write the value of x. So after 10 we have the value of x, which is 101110000010 1111110100. Okay, and let us try to convert it into hexadecimal format with pairing of 4. So this is equals to C, these 4 equals to 1, this equals to 5, we have C15, then 1100 is again C, C15C, then 0010 is 2, then 1110 is E, all ones are F, and 0100 is 4. Base H. Let me write it over here. So the answer is C15 C2 EF4 base H. Now let us see the options. So which option is matching? So we have C15 C2, yes, 0x for hexadecimal, then C15 C2 EF4. So answer is option C. This question belongs to data structure subject and was asked in GATE CSE 2023. So the question states, let A be a priority queue for maintaining a set of elements. So what is a priority queue? A priority queue is a normal queue with normal insertion like a queue, insertion like a normal queue, but prioritized deletion. Prioritized deletion means either we need to delete every time the maximum item or we need to delete every time the minimum item. So this is a priority queue. Suppose A is implemented using max-heap data structure. A priority queue can be implemented using sorted array, using an unsorted array, or using a max-heap. Okay, if we have a maximum priority queue. Max priority queue means every time we need to delete the maximum element. Then it can be implemented using a sorted array, unsorted array, or a max heap. So here it is implemented using a max heap. The operation extract max of A extracts and delete the maximum element from the heap from A. So extract of A basically deletes the max item. The operation insert A key inserts a new element key in A. Okay, so these are basic insert and delete operations. The property of a max heap are preserved at the end of each operations. Okay, so max heap need to be satisfied at the end of both the operations. Let A contains n elements. Which one of the following statement about worst case running time of these two operations is true? Okay, so let us see what is the time for insertion and deletion in a max heap. Okay, so let me draw a max heap for you. So what is a max heap? Max heap is, in this, any node is having maximum value, then its left and right subtree. So here we may have a 50, here we may have a 70. Siblings do not have any relation. Here we may have a 10, 30, 45, 69. Here we have 7, 3. Okay, so this is a max heap. 100 is greater than all these, 50 is greater than all these, 70 is greater than all these, 10 is greater than 7 and 3, and so on. So we have extract max. So how do we perform extract max? So if you want to delete the maximum item, then you basically replace it with the last item. Okay, what's the complexity for replacing? Order of 1. Then you basically delete this last item, its complexity is order of 1. So this is deleted. Now what you do? Then you perform the heapify operation. So what is a heapify operation? See, this max heap is not satisfied here. 3 is less than 50 and 70. In fact, 3 is less than every item in this heap. So we will do the heapify. So in heapify, we will replace 3 by the maximum of its immediate childs. So maximum of 50 and 70 is 70. So we replace 70 with 3. Then we will replace 3 with the max. So 69 will come over here and 3 will go over here. See, this is the heapify operation. See, a max heap is an almost complete binary tree. Okay. And what is the height of almost complete binary tree? It's order of log n. What is the meaning of almost complete binary tree? Which means all the levels will be filled completely and the last level will be filled from left to right. Height is log n. See, the heapify operation need to be performed only on the height of the tree. So what is the complexity for the heapify operation? So its complexity would be order of log n, which is equal to the height of the tree. So delete or extract max will take order of log n. Log. Now let us see the second operation. What is the second operation? Second operation is an insert operation. So we had 100, 70 and 69 and 3. Okay, let me draw it once. Here it was 100, here it was 70, 69 over here and 3 over here. Okay, suppose we want to insert any item. Let us suppose anything, 55. 55 you want to insert. So what are the operations? Add in last. What is its complexity? Order of 1. Now we do heapify. As this is not a heap, see 30 is less than 55. So we need to do heapify. So here we do heapify bottom, which means bottom will ask the top. So here 50 will ask 30. So it's less. So 30 will come over here, 55 will go over here. Then it will ask its parent. So 55 will come over here and 50 will come over here. Then it will ask its parent, but parent is larger, so nothing will happen. So worst case, what can happen? Worst case, we can go till the entire height. And best case, we may do only 1 or 2 swaps. So worst case, it will take order of log n. And even this question is asking about worst case running time. So for insert, what is the complexity? Sum of these, order of 1 plus order of log n, it's order of log n. So what is the complexity? Delete order of log n and insert order of log n. So answer is option B. Both extract underscore max, which is delete, and insert runs in order of log n. So answer is option B. This question belongs to the subject data structures and was asked in GATE CSE 2023. So the question states, consider the C function foo and the binary tree shown below. So this is a foo function and this is a binary tree. When foo is called with a pointer to the root node of the given binary tree, what will it print? So these are our options. So let us see what will it print. So here we have defined a structure for our node. For each node we have a val, like here 10 is the val. We have a node left pointer and a right pointer. Left pointer points to the left side and right pointer points to the right side. Okay, then we have foo function. So foo function is given a pointer. Okay, here initially root is provided. We are provided with root as a pointer. Then it has a return variable. If p is null, which means pointer is pointing to nothing, then it returns 0. Else it computes return value equals to the value of current node plus it recursively calls the left subtree, then the right subtree, and then it prints the return val, and then it returns the return val. Okay, so this question can be very easily done. Let us see how you will do it. Okay, so let us see mark the statements. Okay, let us mark this statement as 1, this as 2, and this as 3. Okay, so first of all, we will provide the root over here. So we will have a return val. Is the root null? No, root is not null. It has a value 10. So we will calculate return val. So what is the value of return val? P value, which is 10, plus it calls the function on the left. So instead of computing this, it came to the left, this node. Now this is the current node. Now what happens? It again initializes a variable return val. Is this 5 null? No. So it will calculate its value 5 plus again it calls on the left. So we have a left value and then a right value. So same over here, 5 plus a left value plus a right value. So it calls on the left. Is the left null? No. So it does 3 plus a left value plus a right value. Now on its left, when it comes on the left, then the pointer is null, so it returns 0. So from the left it came with 0. Now it went on the right, and from right also it came with 0. So 3 plus 0 is 3. It prints 3, so 3 is printed. Third statement is done, and then it returns 3. So 3 comes on the left. Then it goes on the right. So what happens? It has 8 plus the value on the left plus the value on the right. What is the value on the left? It's null, so it will return 0. Value on the right is null, so it will return 0. We will have 8 plus 0, it's 8. So it will print 8, and then it will return 8. So from the right we will get 8. So what is 8 plus 3? 10. 10 plus 5, 15. So it will 8 plus 3, 11. 11 plus 5, 16. So it will print 16 and will return 16. So 16 will come from the left side. Now it will go to the right side. Now what is its value? Its value is 11 plus left value plus right value. On the left it returns 0. So we'll have 0. Now we will go to right. So what will happen? Here it will go 13 plus its left value plus its right value. Right will return 0, left will return 0, and right will return 0. 13 plus 0 is 13. It will print 13 and return 13. So we'll get 13. 13 plus 11 is 24. It will print 24 and it will return 24. So what is 24 plus 16? It's 40. 40 plus 10 is 50. So it will print 50 and will return 50. So this is printed. 3, 8, 16, 13, 24, 50. So answer is option C. Just make sure whenever you are at a node, you compute its value x plus call on the left plus call on the right. And if left is null or any pointer is null, it returns 0. So the answer is option C. This question belongs to engineering mathematics subject and was asked in GATE CSE 2023. So the question states, let u equals to 1, 2, 3 up to n, where n is a large positive integer greater than 1000. Let k be a positive integer less than n. So we have u equals to 1, 2, 3. Then we have k somewhere in between. Then we have n. So k is less than n. Now what we have? Let A and B be subsets of U with cardinality of A and cardinality of B equals to K. So cardinality of A equals to K, cardinality of B equals to K. So as we know that if both had cardinality equals to K and A intersection B equals to phi. So see, we have A as a subset of A being a subset of U and B being a subset of U. We say permutation of U separates A and B if one of the following is true. So either first is true or second is true. All the members of A appear in the permutation before any members of B. Which means, let us suppose we have some part as A. So if we have K over here and some part is A and other part is B and some part is also left over. Let me give you an example for this. Suppose we have U equals to 1, 2, 3, 4, 5, 6, 7 up till 1005, let us assume. And we have K equals to 3. Then what we need to do? We need to basically select 3 items for A and 3 items for B, such that if we suppose select 1, 2 and 4 for A, so 1, 2 and 4 comes for A and 5, 6 and 1005 comes for B. Okay, then all the members of A appear in the permutation before any members of B, which means first of all we will have A and then the item of B will start, because all the members of A should come before any member of B, which means even with the minimum member everything should be before, or all the members of B appear in permutation before any members of A, which means we can take this as B and this one as A, and we can have the same thing. We can't have something like A will have 1, 4 and 5 and B will have 3, 6 and 7. Why? Because here 4 is not less than 2. It's greater than 2. So it won't satisfy the condition A as well as condition B. Any one of them must be satisfied. Okay. Now see, what we need to do. So we have N and we have K. So first of all, we need to select the number of items for A and B, as it is a possibility that K will not have all the items. A and B might have some items, might not have all the items. Let us suppose here A had 1, 2 and 4 and B had 5, 6 and 1, 0, 0, 5. Then many items are left, like 5 is 3 is left, 7 is left, 8 is left, 9 is left. So many items are left. So first of all, out of these all items, we need to select A and B. So A and B has size K and K, which means total 2K elements. So we need to select 2K elements from them. And what about the rest of the element? How many elements are left? N minus 2K are left, which means all these elements are left. Do we have any restriction on them? No. We have restriction only on the items of A and B, which means these N minus 2K elements can be permuted in any number of ways. Okay, now we have selected for A we got 2K items. So 2K items include 1, 2, 4 and 5, 6, 1, 0, 0, 5. Now we need to see half of them, which means exactly K must be A and K must be B. We know the initial K would only comprise of A, as if anything else over here has A, then the B part will be less than A. So the first K would be A. So this can be done in one way. And the second K would be another K. This is for A. We do not need to select anything. The first K part would be A and the second K would be B. Now, they can be permuted internally. We can have 1, 2, 4, 2, 1, 4, 2, 4, 1, 1, 4, 2. So, we have K permutations for A. So, it's K factorial. And let me clear this out. And we have another K factor permutations for B. Okay. So, what is the answer? Let me explain it to you once more and write it more clearly. See, what we need to do? We have total n items. We need to select 2K items for what? For A as well as B. Now leftover items. These are leftover items. They can be permuted in any number of ways. They do not have any restriction. Now A is the first K part is A and the second K part is B. So we got NC2K into n minus 2K factorial. Now see, we will have A and B. A can be permuted in K factorial and B can be permuted in K factorial. Now see, this first and second condition can be used interchangeably, which means this first can be A or this can be A. We can have AB or BA. So we will have two possibilities for this. So it is 2 into NC2K into n minus 2K factorial into A factorial, which means size of that, which is K factorial into K factorial, which can be written as K factorial whole square. So answer is option D. We can write as NC2K is equivalent to N and 2K. This is the same notation as combination. So we have NC2K into 2 into N minus 2K factorial into K factorial square. So answer is option D. This question belongs to the subject discrete mathematics and was asked in GATE CSE 2023. So the question states, let f be a function defined from the set A to set B, be an onto or we can say surjective function, where A and B are non-empty sets. So we have two non-empty sets, A and B, and a function is defined from A to B. Let A has 1, 2, 3 and 4. So it is an onto function and B has A and B, which means all the items of B will have a pre-image in A. So let us suppose 1 and 2 are mapped to A and 3 and 4 are mapped to B. Okay, and let us suppose 5 is mapped to C. So we have a function like this. We have an onto function as no item is there in B which do not have a pre-image in A. An equivalence relation, this is defined on the set A such that A is related to B if f of A1 is equals to f of A2. So if two items have f of A1 equal to f of A2, then we can say A is related to B, where A1, A2 belongs to A. So here 1 is related to 2 and 3 is related to 4. As f of A equals to A and f of 1 equals to 8 and if f of 2 equals to A, f of 3 equals to B and f of 4 is also equal to B. Let E be defined as another relation from the equivalence classes belonging to A with a set of all equivalence classes under this symbol. So what will E have? So see, here what will be the equivalence class of 1? Equivalence class means they will all map to the same thing in B. So equivalence class of 1 will have 1 and 2 as both 1 and 2 maps to A. So what is equivalence class of? See, it is because this equivalence class belongs to A. This set. Thus we are having equivalence class of 1 and 3. What is equivalence class of 3? It contains all the items that maps to the same item, which means it will have 3 and 4. And what will be equivalence class of 5? It will have only 5. Okay, so we have these equivalence classes. So these three things come in the E. Define a new mapping F from E to B. So what all E has? E has 1 as an equivalence class, 2 as an 3 as an equivalence class, and 5 as an equivalence class. It is a mapping from E to B. So what does B has? B had our A, B and C. A, B and C. Where f of equivalence class of x equals to fx for all equivalence classes x in E. So what will 1 map to? 1 equivalence class will map to A, 3 will map to B and 5 will map to C. As for each item, there will be an equivalence class, thus it will be an onto. We can see nothing is left out, so it will definitely be an onto. Okay, and it will be a 1-1. As for each equivalence class, we will have only one mapping, so it will be a 1-to-1. And as it is 1-to-1 and onto, it will be a bijection. So let us see the options. F is not well defined, no. F is well defined. F is onto, yes. F is 1-1, yes. F is a bijection, yes. So answer is option B, C and D. It was an MSQ question. This question belongs to computer network subject and was asked in GATE CSE 2023. So the question states, it is a MSQ type question. So the question states, suppose you are asked to design a new reliable byte stream protocol, transport protocol like TCP. This protocol named myTCP runs over a 100 Mbps network. So what is the bandwidth? Bandwidth is 100 Mbps, megabits per second, with a round trip time of, so what is the round trip time? It's 150 milliseconds, and a maximum segment lifetime of 2 minutes. Here 2 minutes lifetime. So what is the lifetime? It's 2 minutes. Which of the following is our valid length of sequence number field? So we have sequence number field. So what is the length of sequence number field of the myTCP header? Okay, 30, 32, 34 or 36. Okay. So what is the bandwidth? Bandwidth is 100 Mbps. So which means in 1 second How many bits are transferring? We are transferring 100 megabits. It is equals to 100 into 10 to the power 6 bits. If we convert it into bytes, we need to divide by 8. So 1000 into 10 to the power 5 divided by 8. So it's 125 into 10 to the power 5 bytes. So 125 into 10 to the power 5 bytes we are transferring in 1 second. As we know, lifetime is 2 minutes or 120 seconds. So 120 in how many bytes we are able to transfer in 120 second? In 120 second we can transfer 120 into 125 into 10 to the power 5 bytes. What is it equal to? It is equal to 15,000 into 10 to the power 5 bytes, which is equals to 15 into 10 to the power 8 bytes we can transfer in a lifetime of 120 seconds. So what is sequence number? Sequence number bits are always greater than equal to the upper bound of lifetime bytes that can be transferred. Log base 2. So it will be greater than equal to log base 2 15 into 10 to the power 8 upper bound. So what is its value? Its value will come out to be 30.48 upper bound. So it is anything greater than 31 would be fine. So what options are correct? 32, 34 and 36. So answer is option B and C and D. This question belongs to GATE CSE 2023 and the subject name is Discrete Mathematics. So the question states, let x be a set and 2 to the power x denotes the power set of x. Define a binary operation delta as follows, a delta b equals to a minus b union b minus a. Let h equals to 2 to the power x comma delta. It is an operation, delta is an operation. Which of the following statements about h are correct? Option A, H is a group. Option B, every element of H has an inverse but H is not a group. For every element A belongs to 2 to the power x, the inverse of A is the complement of A. For every A belongs to 2 to the power x, the inverse of A is A. So let us analyze the operation first. So what is the operation? A delta B equals to A minus B union B minus A. Let us analyze this by using the Venn diagram. Suppose we have A like this and B like this, then what is A minus B? A minus B is this region, and what is B minus A? B minus A is this region. So we can easily see that this operation delta is equals to our XOR operation. And let us see what all things this delta will satisfy. So we know XOR operation definitely satisfy. It will be closed for sure. So what is the meaning of closed? Which means if we are applying delta operation, then the result will also belong to 2 to the power x, which will for sure belongs to the 2 to the power x, as 2 to the power x is the power set of x has all elements. Like suppose if x is a comma b, then what is power set of A? It has phi, AB and AB. It has all the things that can occur on the elements of X. So thus it will be closed for sure. So closure property is satisfied. Now let us see associativity property. We know this XOR operation is associative. A XOR B XOR C is equals to A XOR B XOR C. So we can easily see that it is associative as well. Now let us see the third property, which is existence of identity. So what is an identity element? Any item E can be said to be an identity for an operation delta if A applied with the operation with the identity gives the same element. So what can be the identity? Let us see if phi can be an identity or not. So what is A delta phi? So A delta phi equals to A minus phi union phi minus A. So A delta phi, what is phi subtracted from any set will give the same set. So we will have A, and anything subtracted from phi will give phi. So we will have A delta phi equals to A. So inverse identity exists. Identity exists, and what is identity? Phi is our identity. Now let us see whether an inverse exists or not, and what is the inverse for an item. So what is the inverse? Suppose we have A Then the A inverse is any item. A inverse, let us suppose write it as x. X is the inverse of A. Is any item such that when delta operation is applied on A and X, then it gives A. So what can be the inverse? Can the inverse be the same item, or it can be the complement? As we have two options, the inverse of A is A, or the inverse of A is the complement of A. So let us do inverse of an item to be the same item. So we will have A minus A union A minus A. So what is A minus A? It's phi union phi. So A delta A equals to phi. Sorry, here it will be A delta x should be equal to the identity element. Then x will be called the inverse of A. So A delta A equals to phi, and phi is the inverse. So inverse exists and inverse is the same item. Why the inverse can't be the complement of an item? I will show you. Okay. Suppose we have A delta A complement. So what will be its value? Its value will be A minus A complement union A complement minus A. So what is A complement? A complement has everything that A do not have. So what will be A delta A complement? So A complement subtracted from A will give A, and A subtracted from A complement will give A complement. What is A union A complement? It is universal set, which is not equal to our identity element phi. Thus A complement is not an inverse for A. So what all options are correct? As it satisfies closure, associativity, existence of identity, and existence of inverse. So H is a group for sure. Every element in every element in H has an inverse, but H is not a group. False, as H is a group. For every A belongs to 2 to the power X, the inverse of A is complement of A. No. The inverse of A is A. Yes. So it was MSQ question, and the answers are option A and D. This question belongs to computer network subject and was asked in GATE CSE 2023. So the question states, suppose in a web browser, you click on the www.gate2023.in URL. So this is the URL we are clicking in our web browser. The browser cache is empty, which means this page is not present in our browser. The IP address for this URL is not cached in your local host, which means we do not have this IP address for this URL. So we need to basically go to DNS. So a DNS lookup is triggered by the local DNS server deployed on your local host over a three-tiered DNS hierarchy. So we have three-tiered DNS hierarchy, which means root level DNS, authoritative DNS, top level server, and authoritative DNS servers. So we have three DNS servers in iterative mode. In iterative mode, which means one round trip type over here, one over here, and one over here. Okay. No resource records are cached anywhere across all DNS servers, which means in the root server, in top level server, and in authoritative server, there is no caching. Let RTT denote the round trip time. So RTT is basically the round trip time between your local host and the DNS servers in DNS hierarchy. The round trip time between the local host and the web server hosting the www.gate2023 is also equal to RTT. So which means we have three RTTs for this DNS, and then we have one RTT for getting our basically the web page from our server. Okay, the HTML file associated with the URL is small enough to have negligible transmission time and negligible rendering time by a browser. So rendering time equals to 0, and file transmission time equals to 0, which references 10 equally small objects on the web server. So we have 10 objects on the web server. Which of the following statement is correct about the minimum elapsed time between clicking on the URL and your browser fully rendering it? Okay, so we have to tell for the non-persistent and persistent STP. So non-persistent STP with 5 parallel TCP connections. Okay, so let us suppose in case of persistent, what will be the timing? So default mode will be like we will have 3 round trip time. 3 round trip time will be there. for 3 round trip time will be there total. So how it will be? One for connection establishment, TCP connection establishment. Okay, one for 10 objects, sending these objects as sending HTTP file as 0, and one for termination. Connection termination. This is the default case. Okay, now let us see for the persistent and the non-persistent HTTP. See, in the iterative mode, this is for basically sending this connection only has 3 round trip time. Okay, but see, this DNS also has 3 round trip time. And in iterative mode, DNS has 3 round trip time. One for root server, one for top level server, and one for authoritative DNS server. So total in persistent HTTP with pipelining will be 3 for this, sending of file connection establishment, sending 10 objects, connection termination, and 3 for these DNS. So persistent has 6. So let us see. 5 for persistent with pipelining, no. 6 round trip time in case of persistent HTTP with pipelining. Yes, this is correct. Now let us see for the non-persistent HTTP, how many round trip times will be there. Okay, so if we have the non-persistent HTTP connection, okay, so we will have 3 round trip time for iterative DNS, as one for root server, one for top level server, and one for authoritative DNS server. Okay, and then we will have 2 round trip time in which one for connection, and 5 for TCP parallel images. Okay, and then we have another 2 round trip time. In this, one will be for connection and 5 for TCP parallel images. Okay, but here we will have 2 extra. Why 2 extra? As we need to have the 1 round trip time for connection initiation, for connection establishment, and 1 round trip time for connection termination. So let us count the total for non-persistent. 3 for DNS, 3 plus 2 for 5 images, plus 2 for another 5 images, 1 for connection establishment, and 1 for connection termination. So we have 3 to 5, 6, 7, 8, 9. So we have 9. 9 for non-persistent HTTP. So answer is option C and D are correct. 9 for non-persistent and 6 for persistent HTTP with pipelining. This question belongs to the topic Engineering Mathematics and was asked in GATE CSE 2023. So the question states, consider a random experiment where 2 fair coins are tossed. Let A be the event that denotes heads on both the throws, B be the event that denotes head on the first throw, and C be the event that denotes head on the second throw. Which of the following statements is true? A and B are independent, A and C are independent, B and C are independent, and probability of B divided by C is equals to probability of B. Okay, so what is the sample space for tossing 2 heads? So either we will get both head or head tail or tail head or tail tail. Okay, so what is A? A is given as A with the event that denotes heads on both the throws. So here we have just head head. And what is B? B is the event that denotes head on the first throw. So here we will have head head or head tail. Okay. C is the event that denotes head on the second throw. So here we have head head or tail head. Okay. Let us find the probability of all the events. The probability of A is 1 by 4 as it has only one item out of the 4 items. Probability of B is 2 by 4 as it has 2 items out of the 4 sample space, and probability of C is 2 by 4, or we can say 1 by 2. Okay. Now let us find out the intersection probabilities. So what is probability of, let us find out first the intersection values. So what is A intersection B? So A has headed and B has headed and head tail. So the intersection is headed. And what is its probability? Probability of A intersection B is equals to 1 by 4. Okay. And what is B intersection C? B intersection C is headed. And what is its probability? Probability of B intersection C, as it just has one item, so it is 1 by 4. What is A intersection C? A intersection C is headed. What is its probability? Probability of A intersection C is 1 by 4. Okay. Now let us, for independent events, so if two events x and y are independent, then probability of x intersection y is equals to probability of x into probability of y. So let us check in this case. So what is probability of A into probability of B? So probability of A is 1 by 4 and probability of B is 1 by 2. So it's equal to 1 by 8. So it is equals to 1 by 4 into 1 by 2 is 1 by 8. Is 1 by 4 equals to 1 by 8? No. So A and B are not independent. A and B are not independent. What is probability of B into probability of C? It's 1 by 2 into 1 by 2 is 1 by 4. So as probability of B intersection C is equals to probability of B into probability of C, thus they are independent. B and C are independent. So what is probability of A into probability of C? It's 1 by 4 into 1 by 2, which is 1 by 8. These are not equal, thus A and C are not independent. Now let us see this part. Probability of B divided by C. Okay. Let me take a different color. Yes. So what is the value of probability of B divided by C? It is equals to probability of B intersection C divided by probability of C. It's the formula for this. Okay. So what is the probability of B intersection C is 1 by 4. Okay. And what is the probability of C? Probability of C is 1 by 2. 1 by 2. So what is its value? Its value equals to 2 by 4 or 1 by 2. We need to check whether it is equal to probability of B or not. Probability of B is 1 by 2. So both are 1 by 2. So option D is also correct. So it was an MSQ question and answers are option C and D are correct. This question belongs to algorithm subject and was asked in GATE CSE 2023 and the topic name is time complexity notations. So the question states, consider functions function 1 and function 2 expressed in pseudocode as follows. So this is function 1 and this is function 2. So in function 1 we need to tell let f1n and f2n denote the number of times the statement x equals to x plus 1 is executed in function 1 and function 2 respectively. Which of the following statements are true? So basically we need to find out the complexity of these x equals to x plus 1 in both these function 1 and function 2 and compare it. So let us see what is happening over here. So here we have function 1. So here we have a while loop over n is a variable, okay, and we have a for loop over the same variable n which is executing n times, and then we have x equals to x plus 1, then we have end of for loop, then we divide n equals n by 2, and then we have end of while. Okay, so let us see. Initially the value of n will be n only. Okay, so the variable n initially has, let us suppose, n value. Okay, so this for loop will be executed n times, which means x equals to x plus 1 is executed n times. Okay, then we do n equals to n divided by 2, so the value becomes n by 2. So this for loop is executed for I equals to 1 to n by 2. Okay, so x equals to x plus 1 is executed n by 2 times. Okay, then again n is again divided by 2, so it becomes n by 4. N by 4. And we have the loop for I equals to 1 to n by 4. So x equals to x plus 1 is executed n by 4 times. Similarly, next time it will be executed n by 8 times, n by 16 times, and so on. So we can write it as n into 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. And this term is basically equivalent to log n. So we have complexity as n log n. So what is f1n? F1n is equals to order of n log n. Okay, let us see f2n. So here we are looping from I equals to 1 to 100 into n, and we are executing x equals to x plus 1. So directly f2 will be equals to order of 100n, or we can say f2 of n equals to order of n, and we have already found out that f1 of n equals to order of n log n. So let us see all the options one by one. So it is saying f1n belongs to theta of f2n. So f1n belongs to theta of f2n. No, theta is not possible as it has log n term extra. Theta is not possible. Theta is possible when we have both big O and omega. But here f1 is big O but not omega. So let us see, f1 is small o of f2n. f1n is small o of f2n. So no, this is also not true as it is omega. Okay, f1n equals to omega of f2n. f1n is log n and f2n is order of n. f1n of n is greater than f2n. So therefore omega is true. Big O, no, small o is false and big O is also false. And as small o and big O is false, theta is false. So only omega is true. So answer is option C. This question belongs to the subject graph theory and was asked in GATE CSE 2023. And the topic name is graph coloring. It is a MSQ type question, multiple select question. So the question states, let G be a simple, finite, undirected graph with vertex set V1 to Vn. Let delta of G denote the maximum degree of G, and let n equals to 1, 2 and so on denote the set of all possible colors. Color the vertices of G using the following greedy strategy. So we have this strategy for basically graph coloring. It is asking which of the following options are true. So what is the strategy? For I equals to 1 to n, which means for all the vertices, what strategy it is using? It is using color of Vi is the minimum of color of J belonging to N such that no neighbor of Vi is colored J. Okay, which means if this is a particular vertex that we want to color, then among the available colors, which is 1, 2, 3, 4 up till N, we will use the minimum color such that none of its neighbors has that color. Let us suppose the graph looks something like this. Yeah. Now, none of them has been colored. So this will get the color 1. Yes, for sure. Now let us see for this vertex. Its neighbor minimum is 1, but its neighbor has 1. So it will take 2. Minimum is 1, but neighbors has 1 and 2. So it will take 3. It can take 1 as none of its neighbor has 1. It can't take 1, but it can take 2. So first option is saying this procedure results in a proper vertex coloring. What is a proper vertex coloring? Which means every adjacent every pair of two vertices, two adjacent vertices should get different color. This condition is satisfied over here. Why? As you can easily see, the color will be such that no neighbor of Vi is colored with that color. So if we have 2 over here, we can't have 1 as 1 is already given to its neighbor. So definitely it is proper vertex coloring. Now let us see the second option. The second option says the number of colors used is at most delta of G plus 1. Okay, so delta is maximum degree. Let us suppose we have a vertex like this and it is connected to delta vertices. Okay, so it is connected to V1, V2, V3, V4 and so on up to V delta. Okay, and what can be the color of these vertices? We can have any color given to those vertex based on this condition. But what can happen in the worst case? In worst case, assume that this gets a color 1, this gets color 2, this gets color 3, this gets color 4, and this gets color delta. So what will be the color of the middle vertex, which is vertex A? It can't have 1, 2, 3 up till delta, so it will definitely have delta plus 1. And delta is a maximum degree. So in the worst case, a vertex can be connected to all the vertices and all the vertices can have different colors. So in worst case, we can go up to delta plus 1. So option B is also true. The number of colors used is at most delta. No, it's delta plus 1 and not delta. So option C is false. Now let us see option D. Option C is false. The number of colors used is equal to the chromatic number of G. Okay. So what is the problem of finding the chromatic number? It's basically a NP complete problem. Okay. And if this algo, this is a polynomial algo. This is a polynomial algo. And if this algo can give the chromatic number, which means the number of colors to color a particular graph, then we can basically prove that the graph coloring is a p-type algo. And thus we can prove p equals to np, but this is an open problem and it can't occur. I will give you a counter example for this. Suppose we are coloring this graph by using this algo. So we have the graph, suppose like this, over here, then over here, then over here. Let us name the vertices A, B, C, D, E, F, and G. Let us color it by this algo. So let us take the first vertex to be this and color it with 1. Okay, now what can be the color of yeah. Okay, let's do one thing. Let's take this as the first vertex and color this as 1. Okay. So what can be color of this? It can't have 1, so it will have 2. Okay. What can be color of this? It can't have 1. What can be color of this? Let us assume this. It can't have 1. Okay, so it will have 2. Okay. Greedy means we can go to any vertex. Now let us suppose this. It can't have 1, it can't have 2, so it will have 3. Okay. Now let's come to this. It can have a 1, yes. Now let's come to this. It can't have 1, it can't have 2, it can't have 3, so it will have 4. Let us come to this. It can have 1. So it is 4 colorable. Okay. Now let us try to do this by another method. By using intuition. By taking some other set of vertices. Okay. Other way. So let us first of all color this. Okay. We have colored this with one color. Okay. Then one color can be given to over this, maintaining the property of the proper vertex coloring. Yes. And this one can't have 1, so this will have color 2. This can't have 1, but this can have color 2. Okay. This can't have 1, can't have 2, but it can have color 3. Yes. This can't have 1, can't have 2, but can have color 3. Yes. This can't have 1 and 3, but can have 2. Here we have colored it with 3 colors. So we can easily see that this algo do not give the number of colors equal to the chromatic number of G. So this option is also false. So answer is option A and B are true according to MSQ. This question belongs to algorithm subject and was asked in GATE CSE 2023. So the question states, let U be a set having the elements 1, 2, 3 and let 2 to the power at U denote the power set of U. Consider an undirected graph G whose vertex set is 2 to the power U. So we have U equals to 1, 2, 3. So what is 2 to the power U? 2 to the power U will have elements like 5, 1, 2, 3, 1, 2, 1, 3, 2, 3 and 1, 2, 3. It will have 8 elements. An undirected graph whose vertex set is U. Okay, so we have a graph having U as its vertex set. So let us draw the vertices. 5, 1, 2, 3, 1, 3, 2, 3, 1, 2, 2, 3, 1, 3, 1, 2, 2, 3, 1, 3, and we have 1, 2, 3. So these are the vertices. Then it says for any AB belongs to 2 to the power U. So for any item A comma B, A comma B is an edge in G. So an edge, we have a condition for edge. If the is that the first item shouldn't be equal to the second item, which means there is no self loops. Like 1 doesn't equal to 1, which means there shouldn't be a self loop on us an item. And either A is a proper subset. This is basic. Either we can write proper subset like this, or we can write proper subset like this. Which means either A is a proper subset of B or B is a proper subset of A. Okay. So what edges will be there? So phi is a proper subset of every set. Yes. So we will have edge from phi to everyone. 2, 3 and to 1, 2, 3. Okay. Then 1 is a proper subset of 1, 2. 1 is a proper subset of 1, 3. And 1 is a proper subset of 1, 2, 3. Yes. 2 is a proper subset of 1, 2. 2 is a proper subset of 2, 3 and 2 is a proper subset of 1, 2, 3. and we have 3 is a proper subset of 1 3, 3 is a proper subset of 2 3, and 3 is a proper subset of 1 2 3. Yes. And then we have 1 2 is a proper subset of 1 2 3, 2 3 is a proper subset of 1 2 3, and 1 3 is a proper subset of 1 2 3. Now it says yes. For any vertex A in G, the set of all possible orderings in which the vertices of G can be visited in a breadth first search starting from A is denoted by B of A. So B of A is basically the cardinality of the number of BFS possible starting from A. If phi is the empty set, so we have phi over here, then it is asking the cardinality of B of phi. So what is its meaning? Number of breadth first searches starting at phi. So here, as we know, phi is a proper subset of every set. Proper subset of every set. Yes. And we can also say that thus we will have edge from phi to every other possible set of this. We will have 7 edges from phi to 1, 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2, 3. And if we have this edge, then which means from phi we can go to any vertex, and then which means from phi we have 7 possible pairing, and these can be organized in 7 factorial ways. So the answer is basically 7 factorial. Let us calculate 7 factorial. It's 7 into 6 into 5 into 4 into 3 into 2 into 1, which is equals to 5040. So the answer basically is 5040. So the main point is that phi is a proper subset of every set, which means from phi we can go to any other set, and they can be organized in 7 factorial ways. And we can go from the point A, if we can go to A as well as B as well as C from a point X, then these ABC can be organized in 3 factorial ways, either ABC or ACB or BAC or BCA or CAB or CBA. Thus, we have n factorial over here. So for 7, we have 7 factorial, and its value equals to 5040. This question belongs to operating system subject and was asked in GATE CSE 2023. So the question states, consider the following two-dimensional array D in the programming language, which is stored in row major order. Okay, so we have an array of size 128 cross 128. So what is the meaning of 128? Indexing is from 0, 1, 2 up till 127, and then in another axis also it is from 0, 1 to up till 127. So we have this two-dimensional array of size 128 cross 128, and the size of name of the array is D. Demand paging is used. First of all, let us see what is the meaning of row major order. Row major order means elements will be stored like this. If we have an item A over here, B, C, D, E, F, which means then first A will be stored, then the second item, then third item, first row, then second row, then third row, then fourth row. Row major order means first row followed by second row, followed by third row, followed by fourth row, and time. Okay. Demand paging is used. What is the meaning of demand paging? Demand paging means initially empty main memory, which means initially no page is there in the main memory. Is used for allocating memory, and each physical page frame holds 5 and 12 elements. Okay, so we have a page and it can have only 5 and 2 elements of the array D. So what is the meaning of 5 and 2 elements? So 5 and 2 elements means we can say either 4 row, as it is stored in row major order. So it can easily store these 4 rows. What are the number of elements will be there? 0 to 127, 128 elements into 4 rows, which is 5 and 2 elements, which means it can store 4 rows. One page equals to 4 rows. One page has 4 rows of D. Okay. The LRU page replacement policy is used by the operating system. So we are using LRU. LRU means least recently used, which means the page that has referred in the past will be replaced. The one which has been least recently used. A total of 30 physical page frames are allotted to a process. So we have page 1, page 2, page 3 up till page 2, page 3, we have up till page 30. Okay, which executes the following code snippet. Okay, so we have a physical page frames. Only 30 frames are allotted to the process, and initially all of them are empty. Initially, all the 30 frames are empty like this, as we are using demand paging. Initially, all the frames are empty, and one page can store 4 rows. Okay, now let us see. So what happens when we run this code? For int I equals to 0, I is less than 128, I plus plus. For int j equals to 0, j is less than 128, j plus plus. dji equals to dji into 10. See, this is here it is stored in row major order, but the access is in column major order. How do I know it? Know this? For I equals to 0, for j equals to 0. So initially I will be 0 and j will span from 0, which means if we have, let me write it like this. If we have an I, we have an J. So initially what will happen is that, let me write over here, I and J. Initially I will be 0, okay, and J will span from 0 to 128, which means 0, 1, 2, 3 up till 127, and I will be 0 in all the places. Then I will become 1, J from 0 to 127, I will be 1. Then in the same way I will reach till 127 and J will go from 0 to 127. Okay, so this will be the mapping. So it is basically column major mapping. Why? Here this index is 0 0, this is 0 1, this is 0 2, this is 0 3, this is 0 comma 127, this is 1 0, this is 1 1, 1 2, 1 3, 1 comma 127, this is 2 0, this is 3 0, this is 4 0, this is 5 0, this is 6 0, this is 7 0 up till 127 comma 0. See, now what happens? Initially I is 0 and j is 0. So we are accessing what item we are accessing? dji. dji means 0 0 we are accessing. Okay, so for 0 0 it will have 512 elements. So one page having 512 elements, which means all these 4 rows will be brought to our this physical frame. Here we will have all the 4 rows from R1 to R4. We will have all the 4 rows. Okay. Let us see what is the next item. Next, J will become 1 and we will access D10. Then we will access D10, which means this item. Then J will become 2, we will access D20. Then D30. All these items will be present in the physically in the frame. This frame will have all these 4 rows, so all these 4 items will be there. So for these 4 items, for these 4 rows, we have 1 page miss and 3 hits. Okay, now what happens? Then we will try to access 2030. All these are hits, this is a miss. Then we will access D40. D40. But see, D40 is not present. So we will bring this page. So we will bring the page which will have from R4, R0, R1 to R4. Then we will have, let us see, R0 to R3. Then we will have R4 to R7. Okay, so 40 will be a miss, but 50, 60, 70 will be hits. We will have 1 miss and 3 hits. So if we continue it like this, which means for 4 items there will be 1 miss initially. So it will continue like this. And how many pages do we have? So we will go in till like 120, till 120 we will go, and we will have 120 divided by 4, which means 30. We will have 30 misses till then, 30 page faults. Then what will happen? Then we will try to access 121,0. 121,0 will be a miss, but this is entirely filled. Here we will have all the pages from P1 to P30. This is entirely filled. Now we will use this LRU page replacement algorithm. So least recently used was P1. So P1 will be replaced, and then another row which is R. What will it have? It will have 121, 121, 122, 123, 124. See, the last one will be 27, 126, 125 and 124. So this will be 23, 22, 21, 20. 20, 21, 22, 23. This will come over here. So we will have another hit miss. Then we will have 4 hits similarly like this. 121 0, 122 0, 120 0, 121 0, 122 0, and 123 0 will be a hit and one miss. Then again there will be a miss, so this will be replaced for the next, which means for every 4 items we are having one miss. Okay, so how many total items are there? We have 128 cross 128 items, and for each 4 items we are having one miss. So what is the total number of miss? You will calculate it to 2, 64, 64. So 64 into 64 is 4096. So the answer for this is 4096, because we are storing in row measure order but accessing in column measure order. First column, then second column, then third column, then fourth column. So answer is 4096. This question belongs to the subject operating systems and was asked in GATE 2023. And the topic name is paging, or you can say multi-level paging. Multi-level paging. So the question states, consider a computer system with 57-bit virtual addressing. So we have a virtual address of size 57-bit virtual address. Okay. Then using multi-level tree structured page tables with L level paging. So L level, we have an L level paging. Okay. For virtual address to physical address translation. The page size is 4 KB. So what is page size? It's 2 to the power 12, or we can say 4 KB, 2 to the power 12 bytes, with 1 KB equals to 1024 bytes. And a page table entry size. Page table entry, what is the size? It's occupies 8 bytes. It occupies 8 bytes. 8 byte, or you can say 2 to the power 3 byte. Okay. The value of L is, so we need to find how many levels of paging do we have. Okay. So if virtual address is 57-bit, then what is the size of process? Process size. You can say it is equals to 2 to the power 57 byte process. Okay. And how it is, this 57 bit is divided? This is divided into page number and page offset. What is the size of page number and what is the size of page offset? See, this entire is 57. Page size is 2 to the power 12 bytes, which means 12 bytes for page offsets and 45 bytes for page number. Okay, so we have 45 bytes for page number. So if we have 45 bytes for page number, then here we can directly see that in the process which has been divided into pages, there will be 2 to the power 45 pages in the process. Okay, so what is, so we have 2 to the power 45 pages. So for these pages, what is the page table entry size? Let us, page table, what is the page table size? So page table size would be page table entry size, page table entry size into number of page table entries. So page table size equals to, what is the page table entry size? It's 2 to the power 3 bytes. And what are the number of page table entries? Is 2 to the power 45, which means 2 to the power 48 bytes. Now see, this 2 to the power 48 bytes can't come in a single page, as a single page size is 2 to the power 12 bytes. So here we will do the paging. So if we do the paging, then how many pages do we have? We have 2 to the power 48 divided by, what is the page size? 2 to the power 12. So we have 2 to the power 36 pages. And what is the page table size? Page table size, it is equals to page table entry size, which is 2 to the power 12, into number of page table entries, it's 2 to the power 36. Wait, just a second. So we have page table entry size is 2 to the power 3 into number of pages is 2 to the power 36. So we get 2 to the power 39. It can't come in a single page, thus we will again do paging. So here, how many pages will be there? So in the third level, there will be 2 to the power 39 divided by page size 2 to the power 12, which is 2 to the power 26 pages. Then what is page table size? So page table size is page table entry size 2 to the power 3 into 2 to the power 26. it will come out to be 27. Sorry, 39 minus 12 is 27. So we have 2 to the power 27 into 2 to the power 3, which will come out to be 2 to the power 30. So see a trend. There is no point of doing this again and again. See, here initially we had 2 to the power 48 bytes page table size. Then it gets reduced into 2 to the power 39 bytes. What is the difference? 39 minus 48, 9. Then it gets reduced to 2 to the power 30 bytes. What is the difference? 9. So now it will get reduced to 2 to the power 30 minus 9, which means 2 to the power 21 bytes. Then it can't come in one page because page size is 2 to the power 12. Then it will get reduced by 9 to reach 2 to the power 12 bytes. And see, 2 to the power 10 can come exactly in a single page. Here we need to make an assumption that the outer page table will come exactly in a single page. So here, how many levels of paging do we have? One over here, 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 and one over here. So the answer is we have 5 levels of paging. So the value of N is 5. This question belongs to the subject data structures and was asked in GATE 2023. And the topic name is Q and stacks. So the question states, consider a sequence A of elements. So we have 5 elements, A0 as 1, A1 as 5, A2 as 7, A3 as 8, A4 as 9, and A5 as 2. The following operations are performed on a stack S and a Q. So we have a stack S and we have a Q denoted by Q, both of which are initially empty. So here we have the operations. The top element of S after executing the above operations is. So let us execute the operations. So S follows a stack. So what is stack? Stack is last in, first out. Okay. So the element which got last in will be popped out first. What is a queue? Queue is first in, first out. Okay. This is last in, first out. This is first in, first out. Push the elements of A from A0 to A5 in that order into S. So we will push in stack. So we have 1 followed by 5 followed by 7 followed by 8 followed by 9 and a 2. Then we have NQ. NQ means pushing or entering the values. So this has push and pop, this has push and pop, and Q has NQ and DQ. NQ means pushing, DQ means popping. NQ the elements of A from A0 to A5. So we have 1, 5, 7, 8, 9 and 2. We have NQ from here, DQ from here. We have NQ from here and DQ. Push from here and pop from here. Pop an element from S. So 2 will be popped out. So 2 will be popped out. DQ an element from Q. So first item which is 1 will be removed. Okay. Pop an element from S. Again, the top which is 9 will be removed. Okay. Then we have DQ an element from Q, which is first item, 5 will be removed. DQ an element from Q and push the same element into S. So DQ will be 7 and 7 will be pushed over here. Okay. Repeat operation 7 3 times. So we have 1, 8 will be DQ and pushed over here one time. 9 will be DQ and pushed over here second time. 2 will be DQ and pushed over here third time. We have stack like this now. Okay. Pop an element from S. So 2 will be popped out. Another pop an element from S. So 9 will be popped out. So we have done this. The top element of stack after executing the above operations is. So top is 8. So answer is 8. This question belongs to compiler design subject and was asked in GATE 2023. And the topic name is syntax directed translation. So the question states, consider the syntax directed translation given by the following grammar and semantic rules. So here the grammar is given and here the semantic rules are given. Here N, I, F and B are the non-terminals or the variables. N is the starting symbol and hash 0 and 1 are lexical tokens corresponding to input letters hash 0 and 1, which means hash 0 and 1 are the terminals, N, I, F and B are the non-terminals respectively. X.val denotes the synthesized attribute, a numerical value associated with the non-terminal x. I1 and F1 denoted occurrences of I and F on the right hand side. So on right hand side we just renamed it I to I1 and F to F1, the occurrences. Then we have I1 and F1 denote the occurrences on the right hand side of a production respectively. For the tokens 0 and 1, 0 dot val equals to 0 and 1 dot val equals to 1. So 0 dot val has a value 0 and 1 dot val has a value 1. So we need to tell the value computed by the translation scheme for the input string. We have this input string. We need to tell what will be the output of this string according to this syntax dialectic translation grammar is rounded off to 3 decimal places. Okay. So let us first, in these type of questions, what you need to do is that you need to basically draw the tree for this string. So we will try to draw it. Okay. So we have, so we will, this is the start. So we will start with n. Okay. So we have n over here. Then we will use the production n derives I hash have. We have I, we have hash, we have f. Okay. Then we have I derives I1b. So which means I derives IB. Okay. Then we have I derives a b using this production rules, and we have b derives a 1. So we have got this one. Okay. Then using b, we can use this production b derives 0. Okay. B derives 0. Okay. We have got another terminal. Then we have f over here. So we can use f derives bf. So f derives bf over here. Then b derives 0. You just need to work out and find how can you derive this using the production rules. So then we will again use f derives bf, then b derives a 1, and f derives a b, and b derives a 1. Okay. See, here we have easily got 1 0 hash 0 1 1. So we have got this. Now what happens? We will traverse it from left to right, top to bottom. So we will come over here, come over here, come over here, and well, on the right hand side we will use the production rules. This rules we will use. So b derives 1. So what was the rule over here? For b, we have b derives 1. So for b derives 1, we have b dot val equals to 1 dot val. And what is 1 dot val is 1, which means b dot val has a value 1. Okay. Then we come over here. Then we have I derives a b. So for I derives b, we have I dot val equals to b dot val, and b dot val is 1. So I dot val is 1. Okay. Then we come over here to the right hand side. Then we have b derives 0. Okay. So if we have b derives 0, then b dot val equals to 0 dot val, and 0 dot val is 0. So b dot val is 0. Then we have over here. Then I derives ib. Okay. So I derives ib. So I dot val equals to 2 into I1 dot val, which is 1, 2 into 1 plus b dot val. B dot val is 0. So we have a value 2. So I dot val here is 2. Okay. Let me erase this as it is making a confusion over here. So we have b derives a 1. Okay. Now we will come over here. Or let me just, we have 1, 1, 2, 0. Let me use a different color for this. So we had 1 over here. We had 1 over here. Sorry. We had 1 over here, 1 over here. We had 2 over here. We had 0 over here. Yes. Now it will be perfect. So we came over here, then moved there, then over here. We came over here. Yes. Now what is this? We will come over here to right hand side. Then b derives 0. So for b derives 0, what we have? B dot val equals to 0 dot val, and 0 dot val is 0. So b dot val is 0. Okay. Then we will go over here. Then b derives 1. So b dot val equals to 1 dot val, and 1 dot val is 1. Okay. Then we will again go, and on the right hand side we will again resolve. So b derives 1. So b dot val equals to 1 dot val, and 1 dot val is 1. Okay. Then we will have f derives b. f derives p. So f dot val equals to 1 by 2 of p dot val, and p dot val is 1. So f dot val is 1 by 2 into 1, which is 1 by 2. Okay. Then we have f derives bf. Okay. So for f derives bf, we have f dot val equals to 1 by 2 of b dot val, which is 1, plus f dot val. F dot val is 1 by 2. So we have 1 by 2 into 3 by 2, which is 3 by 4. So f dot val is 3 by 4. Okay. Then we have again f derives bf. So for f derives bf, f dot val equals to 1 by 2 of b dot val. What is b dot val? 0. Plus, what is f dot val? F dot val is 3 by 4. So we have 3 by 8. So f dot val is 3 by 8. Then we have this production, n derives I hash f. So we have n dot val equals to I dot val, which is 2, plus f dot val, which is 3 by 8. So we have 8 to the 16 plus 3, 19 by 8. So let us solve this using a calculator. So we have 3 divided by 8 plus 2. So it equals to 2.375. So it is equals to 2.375. We need to tell it up to 3 decimal places. It's already up to 3 decimal places. So answer is 2.375 is the value computed by this using this STT. This question belongs to the subject database management system and was asked in GATE 2023, and the topic name is SQL, Structured Query Language. So the question states, consider the following table named student in a relational database. The primary key of this table is roll number. So roll number is the primary key. So here we are given a table with the attributes roll number as a primary key, name, gender, and marks. The SQL query given below is executed on this database. Select star from student where gender equals to female and marks is greater than 65. The number of rows returned by the query is. Okay, so let us analyze the SQL query. So select star. Select star means all these attributes will become a part of the output, which means we will have roll number, name, gender, and marks in the output. Okay. Now let us see which all entries will be there. From student. From student means from this table. Where? Here some condition have been given. Where gender equals to female and marks is greater than 65. As we have used an AND, so both these statements should follow. Let us see one by one. Roll number 1. Gender is male, so this is false. Alia, gender is female and marks is 70 and 70 is greater than 65. So Alia will come. So we will have roll number 2, name Alia, gender female and mark 70 in the output. Then we have Alia as a female with marks 80. Yes, it is a female and marks is 80, which is greater than 65. So Alia will come again, roll number 3, Alia, female and marks 80. Then we have James. James is a male, so it won't come in output. Swati. Swati is a female, but here the second condition failed. Marks is 65. 65 is not greater than 65. If it has been greater than equal to, then Swati will come, but here as it is strictly greater than, Swati will not come in output. So it is asking the number of rows returned by the query. So we have got 2 rows. So answer is 2. This question belongs to Database Management System subject and was asked in GATE CSE 2023. So the question states, consider a database of fixed length records. So we have fixed length records stored as an ordered file. Okay, which means the data files are ordered, which means in a particular order. The database has 25,000 records. So we have 25,000 records, with each record being 100 bytes. So one record is of size 100 bytes, of which the primary key occupies 15 bytes. So we have primary key of 15 bytes. And the other fields then will be 100 minus 15, which is 85 bytes. The data is block aligned in that each data record is fully contained within one block, which means within a block entire record will be there. The database is indexed by a primary index file. So this is the index file, which is also stored in a sorry, which is also stored in a block aligned order file, which means this index file will also be present in a block. Okay. The figure below depicts this indexing scheme. So this is the figure. This is the index file. This is your data file. Suppose the block size of the file system is 1024. So one block is equals to 1024 bytes. Okay. And a pointer to a block occupies 5 bytes, which means block pointer is 5 bytes. So block pointer there is 5 bytes. Okay. The system uses binary search on the index file to search for a record with a given key. So if we have been given a key and we need to search it in that index file, we will use basically binary search. You can assume that a binary search on the index file with b blocks takes log b base 2 block access. So number of block access are log base 2 b its floor. Its seal. Block access in the worst case. Given a key, the number of block accesses required to identify the block in the data file. So we have been given a key and we need to find the number of block access that are required to find the block in the data file that may contain a record with the key in the worst case. Okay, so now let us try to solve this question. So how can we solve this question? So assume we have data file with primary key 15 bytes, other field 85 bytes. Okay. So suppose in this index file, what will be present? In this index file, you will have a block pointer. What is the size of block pointer is 5 bytes. What is the size of primary key? It's 15 bytes. So we can see index entry size. One index entry size will be its primary key size plus block pointer size, which is equals to 15 plus 5, it is 20 bytes. Okay. Now, you know, we have 25,000 records. These records will be present in a block. What is the block size? Block size is 1024 bytes. So number of records per block. How many records will be there per block? So what is the record size? Record size is basically our 1024 bytes. With number of records per block. So block size is 1024 bytes. And what is the size of a particular record? A particular record is 15 plus 85, which is 100 bytes. It's given over here. As we need to find the number of records, we need to take the floor value. So it will be something equal to 10.24 and its floor will come out to be 10. Okay. So we have number of records that can be occupied in one block. Okay. So how many such blocks are required to accommodate all these 25,000 records? So number of blocks required will be equal to total blocks, total records divided by record per block. So it will be equal to 25,000 divided by 10. It is equals to 2500 blocks are required to accommodate all these entire file. Okay, now let us see what will be the, now let me write over here on the right hand side. See, so how an index file will look like. This is the index file. Okay, so let us see number of entries that can occur, number of index file entries in one block, number of index file entries per block. So what will it be equal to? It will be equal to what is our block size divided by what is our entry size. So what is our block size? It's 1024. What is our entry size? Entry size is 15 plus 5. It is 20 bytes. So and we will be taking here the floor. So it will come out to be 51 index field entries can be present in one block. Okay, so how many blocks will be required for this entire index file? Number of blocks required for index file. So how many? So all these, see, here we have 2500 blocks, and for all these 2500 blocks, we will be having one entry. So number of index file entries will be 2500, and 51 entries occupies one block, so number of blocks would be 2500 divided by 51, and here we will take the seal. So why we are taking a seal? Because if we have suppose so this will come out to be 50 point something, 49.01. So see, if we have 49.01, then this extra entry need to be occupied in one block. That is why we are taking a seal. So it is equals to 50 blocks are required for this index file. So we have 50 blocks required for this index file, and 2500 blocks are required for this data file. Now see here, so number of block access, so how many access will be required? So access, we have the formula for this, log base to b, where what is b? B is the number of blocks for index file. We have 50 blocks, so we will have a seal. So it will be equal to plus 1. So it will be equal to 7. Okay, so what we have done, we have calculated the entire thing and came out that the number of block access required are log base to 50 is for finding that file, but we need to also access that file in the database. No, so we will be taking one more block access. So we will be having a pointer, we will go there and access that to for accessing this we have a plus 1. So we have log base to 50 floor, sorry, it's seal plus 1, so it's 7 block access are required. So answer is 7. This question belongs to theory of computational subject and was asked in GATE CSE 2023. So the question states, consider the language L over the alphabet 0, 1 given below. L is the set of all W's belonging to 0, 1 whole star such that W does not contain 3 or more consecutive ones. The minimum number of states in deterministic finite automata DFA for L is. Okay, so let us try to think what can be W. W do not contain 0 or more ones. Will contain null? Yes. Will contain 0? Yes. 1? Yes. 0, 0? Yes. 0, 1? Yes. 1, 0? Yes. 1, 1? Yes. Let us try to think what L won't contain. Okay, so L won't have triple 1, L won't have triple 1, 0, L won't have 0, triple 1, L won't have 0, triple 1, something like 0, 1, 1, 0, 1, and much more. Okay, we can suppose this is L and this is L complement. Thinking about L is more difficult and thinking about L complement is a bit easier. So let us try to draw the DFA for L complement. So what is L complement? We can write L complement to be W contain 3 or more consecutive ones. Okay, so let us try to draw. So first we will draw for 3 consecutive ones, and after 3 ones we will reach the final state. And after that whatever happens we will remain in that state only. Okay, let us name this as A, B, C and D. Okay, now what happens over a 0? We will loop over here only, self loop. Okay, now suppose we counted 1 1 and now we have a 0. So have we made any progress? No, as we need to again check for 3 consecutive ones, so the progress made is 0 and we come back to the initial state. Same over here, progress made is 0 if we encounter a 0 and we come back to this state. So this is for L complement. And you know how can you convert L complement to L? By changing final state, interchanging the final and non-final states. So we will make final state as non-final and non-final state as final. So A will become a final state, B will become a final state, C will become a final state, and D will become a non-final state. Yes. So these are all DFA. What are the number of states? Number of states are 4 states. and it is minimum only as we have designed it from the complement, so it will be mostly minimum, and you can easily see that it is minimal only. The answer is 4 states. This question belongs to computer organization subject and was asked in GATE CSE 2023. So the question states an 8-way set associative cache of size 64 KB. So we have a cache memory of size 64 kilobytes with 1 KB equals to 1024 bytes is used in a system with 32-bit address. So what's address size? Address is of size 32 bits. Okay. The address is subdivided into tag. So we have division of 32 bits like this. We have 32 bits and they have been divided with some part as tag, with some part as index, and the other part as block offset. Okay. The number of tag bits. So it is asking number of bits in the tag. So here the cache memory is divided into blocks. Okay. Here it is divided into blocks. And then some of the blocks are grouped to form a set. So it is 8-way set associative, which means 8 blocks combined to form a set. Okay. Let us assume block size. Let us assume block offset to be of x bits. So block size, what is the block size then? It's 2 to the power x bytes. Okay. What's RAM size? Well, not RAM, what cache size? Cache size is 64 kilobytes, which is equals to 2 to the power 6 into 2 to the power 10, which is 2 to the power 16. 2 to the power 16 bytes. Okay, let me write it properly. It's 2 to the power 16 bytes. Okay, so number of blocks per cache. Blocks per cache. It is equals to 2 to the power 16 divided by 2 to the power x, which is equals to 2 to the power 16 minus x. Now we will see number of sets. So how many blocks? 8 blocks, which is equals to 2 to the power 3 blocks combined to form one set. So how many sets will be there in this block? 2 to the power 16 minus x divided by 2 to the power 3, which is equals to 2 to the power 13 minus x sets are there. 2 to the power 13, it's in the superscript. Sorry, it is over here, superscript. 2 to the power 16 minus x, 2 to the power 16 minus x, 2 to the power 13 minus x. So number of bits for index will be 13 minus x. Let us assume t bits for the tag. Then what is the total size? It's 32. So we will have the calculation like this. 32 equals to tag plus index plus block offset. 32 equals to what is tag? Tag is t. What is index? It's 13 minus x. What is block offset? It's x. This will get cancelled. We'll get it to be 19 bits. So tag is 19 bits. 19 bits. This question belongs to computer network subject and was asked in GATE CSE 2023. So the question states, the forwarding table of a router is shown below. So we are given the forwarding table. A packet addressed to a destination address, this is the destination address, 200.150.68.118 arrives at the router. It will be forwarded to the interface with ID. Okay. So we have a router over here and in the network, and router has this routing table. So what happens? Whenever router gets a packet, router checks in its routing table and then maps according to the relative interface. So how it maps? So it basically does, this will have an IP address. So it will do the logical end of IP address as well as the subnet mask. IP address and subnet mask. And then it will get an ID. Let us suppose ID dash. It will get an ID dash. And then it will map this ID dash. It will check whether it is equals to the subnet number or not. If ID dash is not equal to subnet number, then we will skip. And if ID dash is equals to subnet number, then we will route to given interface. And here make sure one thing, if we are matching with two subnet numbers, let us suppose we AND with this subnet mask and this matches and this one also matches, then we will route to the, in case of clash, in case of clashes, take maximum matching. I will show you what it means. Okay, so let us solve it. Okay, so what is our IP address? Our IP address is 200.150. Dot. Now let us write 68 in the form of numbers. Let me just give it some more space. Yes, 200.150 dot. Now we have 8 blanks. 8 dot, another 8 blanks. So what is 68? Here 2 to the power 0, 2 to the 4, 8, 16, 24, 32. So here we have 8 blanks. So here it will be 2 to power 0, 1, 2, 4, 8, 16, 32, 64 and 128. Okay, so here we have 68. So 64 and 4. So it will be like this. And here it will be, what is the number? 118. So first of all we will have 64, then 64 plus 32, 96. Okay, then 96 plus 106, 96 plus 16, it will not occur. Then 96 plus 8, 104, 104. Okay, I have done a mistake. 1 second, just a second. So here we have 118. So 127 will be 0. We will have 64, yes. We will have 32, yes. So 64 plus 32 is 4 plus 2 6. 6 plus 3 is 9, 96. Okay, it will come. Then 96 plus 16 is 6 plus 6, 12. 112, yes. This will also come. Then we are left with 6. 112, 8 will not come. 4 will come, 2 will come. Then we have 6, which will equal to 118. Yeah, perfect. So here, now the majority part is done. So now we need to check it from starting to top to bottom, or from bottom to top you can check. If we have 255, so 255 means all ones. 255.255.0.0. So these are all zeros. 1, 2, 3, 4, 5, 6, 7, 8. Dot 0, 0, 0, 0, 0, 0, 0, 0. So if we do what we will, whenever we do a dot of 255 with any number, we will get the same number. So we will have 200.150 dot. Here it will be 0 and here it will be 0. Let us see whether it matches or not. Yes, it matches. Okay, so this one matches. Let us check the second one. So what is the second subnet mask? Is 255.255.224. 224.0. So dot 0 is like this only. And what is 224? So we have 1, 2 power 0 is 1, 2 power 1 is 2, to the 4, to the 8, 16, 32, 64 and 128. Okay, so we have 224. So 128 will come, yes. 64 will come, yes. So let us do the calculation. 128 plus 64, it's 192. Then we will have 32, yes, yes, 32, 224, we have 224. Okay, rest all will be zeros. So when we do the dot product, then this will become the same number, 200.150 dot. 1 into 0 is 0, 1.1 is 1, 1.0 is 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, yeah. And here it will be all zeros. So what is it? 2 to the 4, 3, 8, 16, 32, 64. It's 200.150.64.0. Let us check, see whether it matches. Yes, this one also matches. Now let us see the third one. It's 255.255.255.0. Okay. So 255 means all ones. So whenever we are doing a dot with 255, we will get the same number. So we will have the same number, which is 68. 68.0. Let us see whether it matches or not. Yes, this one also matches. Let us see the fourth one. Fourth one is 224. Subnet mask is this 255.255.255.224. So what is 224? It will have three ones, then all zeros. So here we will have 68. Here we will have 1.0 is 0, 1.1 is 1, 1.1 is 1. Here we will have all zeros. Okay. 128, 64, and 92. Okay. So this one will match, and we will get what we will get. We will get 200.150.68 dot what is 64 and 92? 96. We will have this. Whether it is matching or not with this one? No, this is not matching. So this is not matching. So here we have three conflicts. We have three matches. So which one we will take? We will take the maximum matching, which means the one in which the subnet mask is having more number of ones. So we will take the third one and send it to the interface 3. So answer is interface with ID 3.